Hello, you all. Welcome to the tutorial lecture style tutorial on data-driven, never-ending learning question answering system. Before starting, I would love to know to have any feedback from you guys. Whether are you uh, getting me? So listening to me? Did you get my sharing screen? So is it working?
Yes.
Oh, thank you so very much.
Okay.
So thank you for the feedback. I will consider that you are getting the sound and the image. And I got from your chat messages. Thank you so much. And also from audio, which is great because I know everything is working. So from now on, I will turn off my camera just to share the screen and start presenting the tutorials, okay? I'm trying to make it in a way that I can keep an eye on the chat whenever I see any message arriving with questions. This is the idea of not using the recorded video in this tutorial is that you, the audience, can feel free to get in touch to ask questions whenever you need. Yeah, so that's the main advantage of being all of us at the same time here in this session. So feel free to interrupt me, to send me any comment during. I'll try to keep an eye here. If by any reason I do not see it, feel free also to enable your audio and then ask me or say, oh, there's a question there. Okay, I'll do my best to try to answer those. With this setting and technology discussion, initial discussion done, I will just go for the tutorial. Okay, so let me start sharing the screen. Here we go. We should be able to see there and also to see it here. Great. Here we go. So let's do again. Let's say welcome to KDD this Sunday, the first day of KDD this year. This is a virtual conference, unfortunately. I hope we can meet next KDD in person. And welcome to the lecture style note tutorial on data-driven, never-ending learning question answering system. I'm actually very excited to be talking about this topic. The topic goes from two independent, let's say, let me just see whether that's, let me just get used to it and see whether you guys have a message or am I doing it wrong. And sorry about just this double checking, but I think we are good. This is not on us. Oh, maybe I got it. And sorry about that once again. And this is actually from, yes, our VFairs room. Okay, but I'll be mostly looking at the chat in Zoom session, okay? I think it's better if we do that. Okay, so back here, please make sure if you want to have the tutorial locally, is the tutorial slides locally so that you can go through with me, make sure that you go to our tutorial webpage and you download the latest version. So there were some versions there that were not actually the same one that I'm going to use here in this tutorial. So because of that, I would say feel free to go there and double check whether you are using or not the very same one. Yeah, thank you for posting the link here for us. Yes, so you mean if the link is for the slides, this website that we are seeing here, and you might be seeing in my screen, Roberto just did that, and thank you so very much. Great. Okay, so back to business. Just a second. Good. So back to business. I will start making sure that you all have the latest version of the tutorial. And even after the tutorial, this material will be updated. So feel free to come, download, check if you have the latest one or not, okay? Some more on this disclaimer, initial disclaimer. You guys know that we have some time constraints, and I do not intend then to cover all the algorithms, publications, related work, and everything all on both topics, never-ending learning and question answering. Thus, we'll point you guys to recent tutorials and other materials that might help on that topic, okay? I'm just looking at the chat and I see that someone is not able to get access to tutorial link. And when you mean, please, this is Jiang or Jiang, you mean the link to the PDF slides of the slides? Oh, I'll take a look at that. So if you are not being able to download it, please, it should be here. And I'll just check. Okay, yeah, I'm trying to check. So I'm also opening the page. I'm coming to this. To me, it is downloading. Let me go back and refresh to see if is it. PDF is good. Okay, great, 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 great. So I'll keep going because the PDF seems to be working. So it might be local problem if you are not finding out where is the file. So please check your system, okay? Great. Back to our tutorial. We are going to go through this and so I'm not going to focus in the individual parts of this tutorial. What I really want to do here is to give an overview. So that for sure there will be an overview on never-ending learning. For sure there will be an overview on question answering approaches, but those will be shallow and they will be just providing us enough information so that all of us are on the same page so that we can discuss the ideas that would make sense to be put together when we are making a decision of modeling a problem like that. I would just have to, sorry about that, but I'll have to turn off that VFair because those noise signals are actually not helping us. Okay. And please then go for the question answers here in the chat, okay, of Zoom chat. Great. So that's it. We go on the same page and then we discuss the ideas of combinations of possible combinations and strategy for never-ending learning and question answers. You're gonna see this, that slides have lots of text. This is for you guys to have them as a quick reference later on. So sorry if it might look too busy and crowded when we are presenting. So what should you expect from this tutorial? So this is a good thing to pay attention now to see, should I stay in this tutorial for the 3 hours or should I just let it for another time? So what I expect that we are being able to answer when we finish this session is this set of following questions. First one, how the literature usually defines never-ending learning, lifelong learning, continuous learning, lifelong machine learning. So what are all of those? Are all of those the same thing or not? And why should I pay attention on one or the other? Second question, what should I expect when I'm reading a paper that mention one of those topics? Yeah, so it's kind of confusing. So the area is not as mature to really give a good idea easily on all of those. And I'll try to make it a little bit more clear what are we talking about when we mention those different names for the problem, okay? Other questions that we want to answer and we will answer at the end, by the end of this tutorial. What are the key ideas that are present in problems that are modeled as never-ending learning or lifelong learning and so on and so forth? So what's the difference of proposing my machine learning model approach from then making a model or modeling the same problem in a never-ending learning? Yeah, so do I need to use a deep neural network to propose my approaches in a never-ending learning way? or I cannot use it, or I can or not, it depends on my option. So these kind of questions we want to answer at the end of the tutorial. And also, if you have a simple factual question answering system that you want to model or deploy, yeah? So how can you now think about that system that you want to deploy in a never-ending learning frame, or modeling it based on the ideas that we have in never-ending. So that's what we want to do, okay? With examples and going through the literature, showing what has been done and what is yet not known and maybe deserves more action or research. Thank you. With all of this, let me actually start with the motivation for building never-ending learning systems. Usually we know and we see many of those papers mentioning that we know that human learn many different things for years, and we accumulate what we learn, and that makes us better learners over the years. So machines, usually we don't see that. So why we don't see that? In machines, as is very nicely described in this paper from Platano, Safarov, and Mitchell, ICLR this year, 2020, currently machine learning systems are usually very highly specialized. Yeah? They are usually trained for particular problems or domains, and typically they go and their performance is measured and evaluated on single narrow data sets. We don't really go for broader set of tasks that should be answered. So this is the traditional way of doing machine learning. Yeah. On the contrary, human learning, we know it's different. It's highly general, adaptable, and we can easily take past experiences and make them work to help us better learners and better problem solvers, okay? Just one comment on the style of the slides. You're gonna notice that I will usually have reference to the content of the slides here on this corner of the slide, okay? So these comments are extracted from that reference right now. Good. So, you know, knowing all of this, there is also this idea that we don't do machine learning the way we do or the way humans learn, maybe because we don't actually know how learn really works. Yeah? So we have some ideas, some hypotheses, but if we don't focus in building systems that can learn continuously like we do, that can solve many different tasks like we do, that can adapt results from previous experience as we do over the year. And instead of having system becoming obsolete and needing to be changed, the idea would be having systems becoming better and better. And actually, the more I use the system and the older it gets, then I would not really want to change it. If we don't build this kind of system, we are not going to learn. We are not going to understand what are the easy ways or tasks to be solved like that. What are the really concrete barriers that we need to overcome to get there, and so on and so forth. So we need that, yeah? We need to learn about this. And the way to, one of the best ways to learn about this is building systems like that. So based on this motivation, was built the very first never-ending learning system in machine learning. That system is called NELL, which comes or stands for never-ending language learner. And NELL is this system that has as input an initial ontology. And when I mention or talk about initial ontology, what I mean is a set of categories and relations where the categories are usually concepts like people, company, city, so on and so forth. And the relations are actually the relationship between pairs of categories. So a person lives in a city, person works in a company is headquartered in a city, and so on and so forth. Okay, so The main idea here is that we have a never-ending learning system that tries to acquire or learn how to read, how to understand the language, in this case, English, yeah, by reading the web and extracting facts that can be found there. Those facts should be focusing on these initial relations and categories that we set in the ontology. And why do we do that? We do that because actually it might be easier for us to understand the learning if we build one system that has a more specific focus. So we don't want to build the system when it was built. We didn't want to build the system just to go read the web and extract everything, because it's too hard to understand whether everything was extracted. It's too hard to understand whether the behavior or the learning is becoming better and better if you were so general. So the idea here is not going like that, but having a focus, and the focus would be set in the initial ontology. That's the idea that we have right here, okay? With this initial ontology that the user should define, the system also takes a handful of examples for the predicates. Predicates here meaning the category or the relation. So we have, for instance, for the category or predicate person, we would have 10 names of people. For the predicate city, would give 10 names of city, and so on and so forth. And so this is the initial label data that we provide to the system to start building its own knowledge about the language and facts that involve those categories and relations. The system also took or take the web as input, so it can read the web, and it also takes occasional interaction with human trainers. Notice, please, that the occasional interaction with human trainers is not actually pre-scheduled and things that happen on a predetermined period of time. It's just that from time to time, when there is availability of a human trainer, this human could go over part of the knowledge that was acquired and just say, okay, this is wrong or this is right, things like that. And here comes the idea that we are doing this because we would like to have a system that benefits from some interaction with human beings, because this is useful for any learner system that we have, even human beings. Yeah, we are the best. Human beings are still, we are the best learning systems that we know. And we go to school, for instance, when we go to school is to get some interaction with human trainers, because it can boost the speed of which we can learn. So the never-ending learning system can have that too. And the task for now at that time was set as running 24/7 forever. And each day extract more facts from the web about the initial ontology that we want. And then also each day do it better and better than it was done yesterday. Okay, so this is now. And why am I going to start our tutorial talking about NELL? Because maybe NELL is still the very only system that we have out there that can be used or evaluated and assessed that presents characteristics that we want to see in a never-ending learning system. Okay, we are actually from now on going through a bunch of different papers and publications that happened in the area, but we will spend some time knowing a little bit about more about NELL, because the properties and key concepts that we have in that definition will help us to position the other works that are related to this and how different they are and how similar they are to what we see in NELL. Okay, so that's the reason for us to start with NELL as our first paper or work that we are seeing and describing in this tutorial. You can find more details about NELL in this web page. The web page also shows us examples of facts that are extracted from the web. It's very important to keep in mind that NELL's knowledge base or the facts that are extracted, they might not be correct all the time. And the confidence that we use for the system does not mean truth value. So there are things that NELL knows like Chase Bank is a credit union. This is not correct, probably. I think Chase Bank is just a bank, not a credit union. I'm not sure about that, but that's what I would say. And now has confidence 100%. So you see that this does not mean that this is true. What it means is that the system is 100% confident on that. It might be that by reading the web a little bit more, it will find evidence that will make this confidence score go down after it. It happens to us all the time, yeah, human beings. You sometimes think that you are certain about something that is true, and then eventually you find out some evidence that shows you, oh, I was wrong. Yeah, that's not true. It's also something that NELL faces many times. So this is kind of knowledge that is extracted. It, for instance, knows that unnamed subpeak of a long valley peak is a mountain. Probably this is not very useful anyways. It also knows other stuff like tomato is an agricultural product that is usually cooked with salt and so on and so forth. So you can go and check more facts if you want. And what NELL is doing is actually two things. First, growing its own knowledge base. So this is a fragment of the knowledge that NELL acquired and extended from its own readings. So you see here that we have the relations and also the categories and so on. And second thing that NELL does, in addition to be augmenting this knowledge base, is actually recording or acquiring an internal representation of what those facts mean and how it can actually use that internal representation to learn better about other things that we're not seeing yet. Okay, but let's take an overview here on how NELL wants to do that. So growing the knowledge base and creating its own internal representation to make that growing better and better with time. It actually uses concepts of breaking down the big problem in smaller ones. And I will take one of those problems here to try to explain one of the biggest problems with continuous learning, never-ending learning, lifelong learning, whatever, all those topics that we are going to see in this tutorial today. So one of the big problems here is the following. Let's imagine we just want to do the classification of a noun phrase by a category. You can imagine that this is one of the subtasks that NELL needs to solve, yeah? So, okay, if I want to do that, one very simple approach, if I want to keep doing this continuously, would be give a set of examples for this. As I mentioned, NELL takes categories and then takes examples or a handful of examples of those. So let's imagine I want to learn whether a noun phrase is a city or not. So I give some examples of city, then using those examples, I can go and read the web, find sentences that mention those instances there. And I find sentences saying mayor of Pittsburgh, the mayor of Paris, mayor of Seattle, and so on and so forth. So then I discovered that mayor of can be a good context to detect new cities. And I also find that people say, I live in Pittsburgh, I live in Seattle, so on and so forth. So now I can kind of very naively, if I want, go and use these patterns to find more city names. Yeah? If I do that, I will keep reading the web and find sentences now saying the mayor of San Francisco, for instance, Austin, I live in Austin, I live in denial. So you see that if I just keep doing this, in spite of knowing that this is a very naive example that I'm showing here, but it tells us that just keep doing the learning in a continuous way does not guarantee that your system will actually get better. Yeah, it might at the end of the day, instead of making your system getting better and better in solving the task, it might actually bring so much noise that your system will get worse and worse. So that's one of the biggest problems of learning continuously without having any supervision in this sense, or just starting with a very small amount of supervision, okay? If we keep doing this, you got the idea, you know that if I now look for sentences that mention denial, we'll find sentences saying traits such as denial. And then if I use this to find more, you see, I ended up finding so many other things than cities here. And that's a problem. So here comes the very first key idea that I want you guys to keep from now and on, so that we can use this to first compare different approaches of lifelong learning, continuous learning, never-ending learning. And second, to keep this idea, and whenever we are modeling our problem, if it is a question answering, for instance, as we are going to see here in this tutorial, or even if it is a different problem that I want to model, I should keep that idea in mind. And I should say, okay, even if I want to model a problem that given an input has one specific output to be done, yeah, doing it, building a single function that does this might actually make the problem difficult to be set in a continuous learning way. Because if I do that, the answers or the output that I get for this function here can then be reused to relearn the training or relearning or training the model, retraining the model, and then I will start to use wrong labels that were done in this process, as we just saw. So instead of doing that, if you want to go for a continuous learning way, you should actually give or provide to your system more ways that this system can actually find evidences when it is doing a good job, whenever it's not doing a good job, whenever its own findings are consistent or not, and things like that, okay? So this key idea number one, say, instead of building your system focusing on a single task or a single view of this task that you are trying to build it in a way in which you have a multi-view and multitask learning approach, or multi-view and multitask coupling approach, okay? And you see that I'm not for now saying that you necessarily need to have different components in the system, but you can have a single model. But the problem here is your model or your approach must be considering more than one single task, or at least more than one single view for solving that task, so that you can then do the consistency that I mentioned before. Example here, for instance, if you're learning whether a noun phrase is an athlete and that's what you want, also try to learn whether this is a person, or does it refer to a coach or sports team or sports, and so on and so forth. If you learn that, then you have one function or classifier or model saying, okay, this noun phrase is an athlete. Then you have another one in your system saying, okay, this is a person. And then you say, okay, that makes sense because an athlete is a person. And then if you try to classify this and see that the very same noun phrase can also be classified as a sport, and you know that sports are not, and people are not the same thing, so then you start to have some evidence to be in doubt whether that learned piece of knowledge is correct or not. And then you can start not using it, for instance, in the next iterations to retrain your model, and so on and so forth, okay? So in NELL, we have more than 4,000 coupled functions working to help preventing the system to go for what we call this semantic drift, which is start to learning wrong labels and then using those get worse in trying to solve your task after some time. So this is the main idea. And you see also that what I'm presenting here is a way of trying to create different functions or different components in my system to help the system to be more self-supervised, yeah? So for instance, one thing we could have done in NELL would be creating one only model or classifier that, giving a noun phrase, would output what class does it belong to. So instead of having one classifier, binary classifier that take a noun phrase and say, is it an athlete or not? Then another one saying, is it a person or not? And then another one, is it a sport or not? I could have a one only, and it would say, is it an athlete, person, or sport? Yeah, I could have done that. But if I make it very explicit in binary functions as we are here, I can actually break down the problem in many different sub-problems, and then I can use the output of those problems and actually add external knowledge to this whenever it's possible. So that's why now we opt for going for the simpler functions that can be built, and then we couple them together instead of actually just giving it the complexity of the solution to a single model to solve it. We are going to see in some minutes that I'm not here saying that you cannot use a single model. You can, but you should actually pay attention to what are you going to do so that your single model can take advantage of having different tasks or different views performed inside of it. Yeah, so that's the point here. So this is the very first key idea. And with that idea, I'll just show that whenever you have these many different functions, you can start to create the internal representation of your system. And if I have those very simple functions as I described for you, what is most important from NELL, I think, other than just classifying correct whether a noun phrase is from a category or not, is actually to build internal knowledge or internal representation of how to understand the sentences that are being read. So for instance, NELL, taking the initial knowledge that it has, found out that there are some very common patterns here for when you were talking about an athlete. And it found, for instance, that people over the web use a sentence like, Michael Phelps is the Tiger Woods of swimming, which would mean, okay, the guy is really good at swimming, yeah? So you see that this is something that the system can learn and is not actually based on syntax, clues or grammatical rules or whatever. It's just because people used to say it. And if now for NELL, the noun phrases that represent an athlete usually appear in relations like these ones that I'm showing here for you, this is the internal knowledge that is being built. And whenever a noun phrase appears and it needs to classify it, it can use this internal representation to explain. Now can say, okay, I think that Michael Phelps is an athlete because I found many sentences saying that he is the Tiger Woods of swimming. So I think he's a swimming athlete and things like that. So I can explain, yeah? If I found a noun phrase that is a hotel, and I can then say, okay, I think this is a hotel because the suffix of this noun phrase, the last word is hotel, and usually that means, and so on and so forth. So you see that you build it. And it means that you should keep it. You should not throw away this kind of thing, yeah? So the knowledge base that is being created now has the ontology, which would be seen as the triple of facts, yeah? So argument one, relation, argument two. But more important than that is that NELL must store in some sense or in some way all this metadata or all these parameters that are being learned. Because what we have in this case here are parameters that are being used as features for classifiers and models that NELL has, yeah? But in this case, those parameters are symbolic parameters. And whenever you have symbolic parameters, you can say, you can use them to give explanations, as I just told you. So this is very important part of a never-ending learning system. You need to solve your problem, but you should actually acquire all the parameters and the signals that were used to solve the problem and keep them in a way that you can use later on to learn more about them. So in NELL, we use a knowledge representation a schema called Theo, but you don't need to use that. You can use anything you would like to, but you need to have a way to keep the parameters of what your system used to learn and to give the outputs that it gave, okay? That will be very important. And actually, that will be what make the second key idea for a never-ending learning system. So first key idea of a never-ending learning system is never try to solve it in a single task and single view, because then it's too hard to go in a continuous learning, okay? So do it in multi-view and multitask. Second key idea here, use everything that was learned before, yeah? Not only the facts, for instance, for NELL, but the facts too, plus all the parameters that were used to help learning those facts, so that later on you can go and learn more about it, just reading or reasoning and performing inference over the metadata, over what was actually acquired, the knowledge that was previously acquired. So this is key if you are wanting to build your never-ending learning system. In NELL, for instance, we use first order logic to try to extract first order horn clauses, probabilistic ones. So for instance, if you go over the knowledge base, you will find out that if an athlete X plays for a team Z and that team Z plays sport Y, so then it usually means that that athlete X plays they sport Y. Yeah. We also use other ways of doing the reasoning in NELL. We have the path ranking algorithm, for instance. We have some open triangles or closing triangles idea, variations of those that I'm talking. And it's important that we do this also looking into the first key idea, doing it in many different ways. Yeah? So the multi-view way of doing it is also important to be applied to the second key idea in NELL. Okay, so for now, we've seen the very first never-ending learning system is NELL, maybe the only one that we can take the analysis of how does it work. We found out two key ideas on that system. We are going to discuss two more key ideas, and then we will keep going for the other works. So far, so good? Or any questions about those key ideas? How are we going so far? And just highlighting here, what we need to take away from this are these ideas so that we then can compare to other approaches later on. I don't see any question in the chat. If there is a question coming, please keep going. But I will keep going here too with the presentation, okay? And if the question appeared there, I'll be very happy to stop and try to discuss or answer the question, okay? So very, very good. We have covered so far two key ideas of a never-ending learning system. And we now are going for the third one. The third one is the idea that your system, whatever it does or whatever its own main goal should be, if it is to be a never-ending learning system, it should be capable of creating, defining, proposing, and deploying its own new learning tasks. So I told you that we should have multitask, multi-view learning, yeah? And we can provide some initial different tasks to the system. It's important, it helps the system a lot. But with time, we do expect that the tasks that are relevant for solving the problem, the set of tasks that are relevant to solving the problem can be extended by the system itself, because this is a good way to keep improving. Maybe if we don't do that, or if your system is not able to propose new learning tasks, you might end up achieving a plateau in which you cannot really solve any better the problem you are solving based on the data you have, based on the examples you have. So being capable of proposing new learning tasks is important if your system wants to grow indefinitely in the knowledge that it acquires, and if it needs or wants to go in a never-ending learning paradigm. I see a question coming here, which is very, very nice. So, and the question is, how to evaluate such NELL system? Do we evaluate on every view, or is it there a holistic measure? This is awesome question. So I would like to say thank you, thank you, thank you. This is one of the biggest problem of NELL, if you ask me. What are the worst part that you could do when you guys were building NELL? So this is one thing that we could not actually advance much on defining a very nice way of evaluating NELL. And you're going to see that in a few slides next. I will go to this point, and we will point out that because NELL interacts with the web, so the internet, the web is the environment in which NELL interacts with, and it's a very complex and very, very dynamic environment. It's very hard to really use NELL as a benchmark and then actually use, for instance, another approach and compare how a different approach would perform trying to execute the very same tasks that NELL does. So it's very hard to evaluate that. So we have in NELL, this is a very good question, we have in NELL evaluations. And as you can imagine, we built NELL with like different sub projects being developed. And usually we had like PhD students working these pieces or these independent projects. So there were evaluations being conducted in the very specific views or tasks there were, but not necessarily for NELL itself. When we were then connecting or adding those abilities or capabilities or actually tasks and models into NELL, we were measuring how much NELL could benefit in learning more. Yeah. So we did, and we have in this paper, in this paper, Communications of the ACM 2018, we propose an evaluation method in which we freeze all the web pages that could be read, and we don't use, for instance, any model that would actually go beyond those frozen web pages and the initial results that were already in the knowledge base just at that moment in time. And then we try to evaluate how well is NELL doing in terms of proposing correct facts that are extracted from the web. So this is the very general idea of the evaluation that we have. But this is very general, and I would say it helped us a lot on knowing that NELL was improving over time. And you can see in the paper, I don't have slides specifically for that in this presentation, but in the paper you have very nice graphics and discussion about that. But the summary, the takeaway from that is we could notice that NELL kept growing and improving its own ability to learn, but it was really hard actually to do this comparative analysis with other possible approaches and things like that. And that actually motivated the team, even proposing different benchmark approaches that we're gonna see in a minute, okay? So thank you so very much for this. The summary for the answer of the question is there was independent evaluation, but not inside NELL. And then in NELL, we did a holistic measure on wrong and right extraction of facts that were being performed. Great. And one very important thing here that is very related to your question too, is that I'm talking about key idea number 3, yeah? And key idea number 3 says you should create new learning tasks. You should be able, use system, if you are a never-ending learning system, you must be autonomous enough to propose and deploy new learning tasks. But you see that this is something that can be actually dangerous, and we might not want to be just proposing and creating new learning tasks just because the system is capable of it, yeah? So the idea in NELL and the idea in a never-ending learning system maybe should be add by yourself with your own abilities new learning tasks over the time, but just do that whenever you have some ways of measuring that the addition of this extra new learning task will help your system to perform better. So for instance, one way we did on adding new learning tasks for NELL was based on extending the ontology. Yeah. So as I told you, for every category and for every relation in NELL, in NELL's ontology, we would create a function, which can be, for instance, a classifier or a clustering algorithm or any learning algorithm you want to, you think that could be working better, we would do that. Yeah. So it means that whenever we create more categories or more relations and add it to the initial ontology, that addition would, by default, create new learning tasks, because then NELL would deploy one model, a classifier, for instance, binary classifier, as I said, that will be focusing on trying to find facts related to this new relation. So let's give a very simplistic example, and let's imagine that NELL would start trying to learn from an ontology that has only those 4 categories and only those 2 initial relations. Yeah, and let's imagine that NELL has done this and extract many facts and so on. If I just extract, city names based on the ability of classifying or finding name identities by itself, and by finding the relation that a sport is played in a city, maybe there will be many different examples of cities over the web that are mentioned, but now will not be able to extract, because the contexts in which those city names are used do not fall in these classes that we proposed initially in the ontology. So in that case, let's imagine that now NELL could not learn more about sports played in cities. I don't know, something like that. So NELL can go and detect or try to identify new relations that would be related to city. So NELL can take, for instance, all the instances of people that it knows and all the instances of cities that it knows, and now could identify over the web in a relation discovery process, for instance, that yes, many people talk about people and cities, and there are many relations connecting those 2 categories. One of those relations could be lives in. And so then now can, for instance, say, as I achieved a plateau and I'm not learning any new cities anymore, and with that I cannot really find out the sports that are more sports that are practiced or played in that city. So let me add this new relation here. And then by default, NELL would start to create a classifier to try to classify sentences as positive examples of people living in city or negative examples of those. And then I would start to get more examples of cities. And then maybe it would boost the ability of the system to try to find more sports played in cities now that we know more cities. And it can keep growing like this also for categories, not only for relations and so on. So that's the idea of extending the ontology and with the extension, adding new learning tasks. But I don't want actually now to be adding all possible categories and relations that it defines that are possible to be added. We need to use this holistic measure, for instance, that was mentioned in the question, to see, okay, if I add this, does it bring any improvement? Can I see that I'm doing better because of this? Or can I expect to be better because of this? If so, yes, I, as a system, as a never-ending learning system, should add this task. Otherwise, I should not. Otherwise, because if I just keep adding this indefinitely, I will come to a point that at least this system will have so many functions to learn that at least it will be really, really slow or something like that. Yeah, you're gonna see, for instance, in a few minutes that if we are using a single deep neural network approach to do this, then you're gonna get to a catastrophic forgetting, for instance, stuff, or I will not be able to represent everything with the number of parameters that I have because I'm creating so many tasks. You see that independently, whether you are going more in a symbolic system, as we are seeing here, or going more in a neural network approach, just being adding, because you can, adding and adding more and more functions, that's not the case, okay? But the system must be able to, whenever it is beneficial for the system, add new functions by itself. Good, and that's key idea number 3, just giving some examples of how NELL, or some examples of some of the relations that NELL by itself learned and added to the knowledge base. Many people that watch my previous presentation know that the one that I most like is baked good served with beverage. Yeah, but anyways, and I'm just saying this because these namings or the naming of these relations, the names that you see here, were automatically generated by NELL in a simply way of getting the centroid of the most representative, or actually the names or the surface of the tokens in the most representative element in the clustering algorithm that we did. It's very simple, but it gives us some idea of the name of the relations that were found out. Yeah. And I want to mention this because I want to get back to key idea number 3 and say, it's not always the case that the new function that you create, or the new learning task, let's say, that you create, need to have a meaningful name for your user. It's not always the case like that. What is important is that your system finds out a way to add new functions that help it improving in the main goal, yeah, the target learning that it has. Sometimes the system might just add new relations and not naming them. It will be relation 1, relation 2, relation 3, or new learning task 1, learning task 2, and so on and so forth. Okay, that in many situations will be more than enough. I don't need to name them, and it can be like hidden states or things like that. It's okay, but I should provide ways of learning those or proposing those new learning abilities to your system. That's what we should have. With that, we finished key idea number 3, and hooray, because we are getting to the last key idea that we need to know, or that we should take away from the never-ending learning system, so that we can now start comparing and checking with other models. How would that compare? Yeah. And the last key idea is called key idea 4, and it just say that all this multitask, multi-view thing that you do with the ability of reasoning over them and adding or augmenting the set of learning tasks that we have, all of this that we're doing should be done in a way that those tasks and those different views actually contribute to each other. So we don't want to just add those tasks for adding, as I just said. We need to do it in a way that it will cumulatively help your system in what could be, for instance, called a staged learning or curriculum learning based approach or something like that. The main idea here is you should learn or you should have learning tasks that will improve your ability to learn other learning tasks that are important for you too, okay? In NELL's case, we have many different tasks that we used and they were all coupled together to help. As you already saw in a previous slide, we had more than 4,000 coupled functions running in that system. Anyways, so this is the set of 4 key ideas that I want you to keep in mind during this tutorial. And I will just highlight once again, I already talked about that, but I will just highlight once again that those 4 key ideas, they actually allow you to design your system with an architecture and an internal representation that can be used for learning better and better with time. What I mean is that, for instance, NELL last architecture was composed by all of those different components trying to solve different tasks here. And for each one of those tasks, also using different views to solve it, yeah? And at the end of the day, whenever you now get all of this and store the parameters, store the metadata, store the inputs and outputs that were used for all of those functions that you have, you start to have ways of understanding the reasoning that was used by now to say that Michael Phelps is a swimmer. Yeah, so I told about that in the context of more symbolic parameters that we have in now, but we don't need to be using only symbolic parameters here. Yeah, we can also take advantage about from other ways of representing the problem that you are trying to solve. For sure, whenever you have parameters that are symbolic and make sense, we can use them for explanation. But we can also, for instance, now get all this knowledge that was acquired and try to extract or embed them in a dense vector representation, and then try to make sense of these two. So for instance, here you have embeddings from NELL's ontology that are talking or related to the semantic categories. And you see that using everything that NELL learned over the time, over 10 years of learning, you see that these categories like bedroom item, floor item, furniture, wall item, and so on and so forth, they are kind of located nearby in this dense vector representation that you can build from what was learned before. So this is interesting because it tells you, okay, you can now reasoning even if you are not understanding what those numbers or features mean in the vector that is representing what you're saying. So you have ways of going more for numbers and reasoning. You have ways of going more symbolic and then also trying to explain what is going on. Yeah, some examples here also now for the embeddings of the noun phrases instead of the semantic categories only. So now we also have semantic categories and noun phrases that occur together. Yeah, so that's just to give you an idea. And with this, we can summarize. Yeah, we can summarize the idea of never-ending learning that is aiming to bridge this human learning, machine learning gap. Notice that there is no definition that I know that would say that we need to do the never-ending learning exactly as human beings do. On the contrary, actually, this is like we want to have inspiration on how good we can do this flexible way of learning, dynamic, adaptable, and so on and so forth. Yeah. So whenever we go for a never-ending learning approach, yes, we are getting closer to this way of learning that humans usually use. And doing that, it means that we are focusing on building systems that can solve more than one single task. Yeah, we are trying to add many different tasks and then making those interrelated tasks working together, also with different views to get much better results at the end. And as a consequence, yes, it will be able also to work in much more complex environments than if we work with a single function. And I already said it will be closer to this generality and diversity and so on that we have in human learning. So this is some takeaways or summary from this. The key ideas that we saw are here. I just mentioned them some minutes ago, so I'll not spend much on here, but do it in multitask, multi-view learning, then reason over what you did before, autonomously propose, create, and deploy new learning functions and new learning tasks, and do it all in a cumulative and staged learning approach, okay? So key ideas are those. And if I was to summarize some properties that are kind of consequence of those key ideas, is that your never-ending learning system will tend to be self-supervised because it will use all of those different tasks and views and reasoning, etc., to kind of find evidences from for when it is doing right and when it's doing wrong. And it's also most probable that your system will start to get some capability of being reflected or reflect about itself. Yeah. So having the property of self-reflection, it means based on the self-supervision that it has, it can see what is being done correctly and achieving good results and what is not being done correctly and so not achieving good results, and then reflecting on those, the system could propose different ways of doing what is not getting the best results as expected. So those are very interesting properties and that we actually expect to see in never-ending learning systems that we build, okay? This kind of summarizes what we saw from NELL. And here comes again, why did we spend so much time on NELL here? Because maybe that's the only system we have with those characteristics. And so as in this other work here is pointed out, yeah? And unfortunately, or not, I don't know, but it's maybe the only system with those characteristics, and it is actually using the internet as the environment. So it comes back to that great question that was asked before. Yeah, how do you evaluate and so on? So because the internet or the web is actually the environment, it's very difficult to evaluate when comparing to other approaches. Yeah, because you cannot really focus in a particular aspect of the system, because if you're gonna evaluate it over the web, you don't know whether the changes or difference in the results come because of changes in the environment that is so complex, or because of the new ideas that you implemented and so on and so forth. I already talked about that when I was answering the question, so I'll not even spend too much here, but you got the idea. This is not very good to have a system like that. It didn't help the community, I would say. I would say that if NELL were focused in a simpler environment, or in an environment that would not pose so many challenges as the web, maybe the community could be taken more advantage of that. Yeah, and use that in different ways too, which is good. It's not that we should not have done that, because we learned so much and it really contributed to many different things. And maybe it's just the case that now it's the time to also start to think about different things, to start to think also, in addition to learn, build, and deploy and investigate systems like NELL, also have different ways of evaluating, understanding, researching, and investigating never-ending learning systems. Yeah. So if you guys heard about or hear and read about some other related areas to machine learning, for instance, computer vision. Yeah. So whenever we start to have very common and very well-known benchmarks for the tasks, that helped us so much in getting better and better results and advancing the area. It happened, for instance, when we got ImageNet, and then people start to use that as a benchmark, and you see that it boosts the results on the research area. So based on all of this work, which is the second one we are going to point out here in the tutorial, actually proposes a new test bed for never-ending learning. That's what is done here in this approach. And the new test bed is called Jelly Bean World, and actually is proposed as a novel evaluation framework for a never-ending learning system. It's not so complex as the internet, as the web, when NELL was created, but that's intentional, yeah, because then it's a much more controllable environment that you have, and you can try all these ideas that I was describing here that are present in NELL. They are actually reflected in the way that this Jelly Bean test bed set was created. I'm not part of that work of the Jelly Bean. I'm just saying it's a very nice one, and they actually brought ways of having different measurements, and it also comes to answering the question that was posted here before. In addition to propose and have this very nice contribution of making a proposal of a new benchmark for never-ending learning systems, the same work also brings a very nice, and I would say, if you are interested in keep reading after this tutorial, this paper brings a very interesting way of starting to show us some key differences from never-ending learning, continuous learning, lifelong learning, and these other approaches that are all there. Yeah. So let's start. We are also interested in knowing about those differences and similarities. So let's start using what the authors of that paper posted there, and let's keep from there to try to draw here these differences and similarities. Okay. So for that paper, the authors point out that never-ending learning is in many respects similar to lifelong learning, and this is correct. And actually, they all share much of the initial motivation, and so they really share and overlap in many of the ideas that are used And it also points out here that continual learning, which is this work by Chen and Liu, 2018, is similar to the traditional lifelong learning and so on. But never-ending learning and lifelong learning and continuous learning and so on, they are different from multitask, multi-view itself. This is a very interesting point that they mentioned there, and it's relevant for us in the tutorial. Just because you create a multi-view, multi-learning system, it doesn't mean that you are ready or that you are really performing something related to never-ending learning. Yeah, so that's important to keep in mind all the time. We might, for instance, see ensembles of different approaches for the same task. So this would be multi-view, for instance, or we can have systems that integrate different tasks and couple them together somehow, but not necessarily going for using the results that were learned to learn better in the second time and so on and so forth. So they are different. Multitask is really related to what we are doing here, but you need to pose these constraints or this different way of designing your multitask, multi-view learning to allow it to become a never-ending learning system. So this is a very good point. Other points made by the authors is that in never-ending learning, which is not the case for multitask again, and it's not also the case for most of the cases in lifelong learning approaches, and I will be more precise in this in some next slides. So never-ending learning has this way of going beyond a well-defined set of tasks. Yeah, so we don't assume that. As I showed you in now, we can even start with the initial set of tasks that we are interested in, but we don't assume that we have this well-defined set of them. And the system must be able to actually add to it and create its own learning tasks and so on. So this is one, we talked about that in NELL as key idea number 3, yeah? And this key idea number 3 is something that is not really present in many of those approaches called lifelong learning or continuous learning. In multitask learning, it's most never present in simple multitask learning. So this is a very nice characteristic that, as I told you, if you want to build a never-ending learning system, maybe if you don't add this key idea number 3, your system can plateau in what it can learn with time. And if you add this and your system can perform it well, it will help you to actually go beyond those plateaus that might appear in the way and solve better or find better ways to solve your problem. Yeah, so this is interesting. So we start here to make the very first difference or find the very first difference on lifelong learning and never-ending learning. Let's get a little bit back more precise on that in a minute. Also here in that paper, the authors showed this contrast with reinforcement learning, yeah, and never-ending learning. And I heard a lot of times people say, oh, isn't never-ending learning just reinforcement learning? Because, you know, in reinforcement learning, we are kind of trying to get better and better with time by actually taking actions and getting rewards and seeing that we did a good job, so keep doing like that and so on. That's exactly reinforcement learning. Yeah? And it makes sense, it is. But we have some definitions that make a little bit different the way we see never-ending learning. And it doesn't mean that we don't actually that we cannot, for instance, use reinforcement learning for performing never-ending learning. We can, and that's very interesting. Actually, if you guys later on go and check this paper, Platanius, Saparov, and Mitchell, you're gonna see that the way they propose it in the Jelly Beans world is actually a setting of a reinforcement learning to perform the never-ending learning idea. So they can be together, but usually now focus in environment that is really complex, and reinforcement learning, no. Usually in the reinforcement learning, you define initial set of actions, the task you want to solve, and then reward function. And based on that environment, yeah, you go and try to improve your ability to solve your problem. So you see that it's a very, very well defined. So the complexity of the environment usually is much smaller than what we expect for a never-ending learning. Usually in a reinforcement learning approach, we are not creating new tasks. We are trying to use the tasks that are available to solve it better. Let's take, for instance, we want to play Go, yeah? So we have rules, and my idea is to use those and apply it in tasks that I can, or actions that I can perform. And then the learning tasks that I will have will be based on those rules and actions that I have. Yeah, so we have the sensors, the effectors, and I go for this environment that is well defined. So that's usually what happens. And in never-ending learning, we are trying to go also for the idea of, sure, getting better with time, using what was previously learned, but also proposing new tasks so that can make us escaping from plateaus and from areas, let's say, of the search space that are not taking us anywhere else. So this is something that we try to have in a never-ending learning system. Another characteristic that usually is present in reinforcement learning is that you have episodes, yeah? So you run your episodes and then you can have your agent in many of those and so on. We, in never-ending learning, usually are very interested in trying to understand how can you go learning without resetting the episode and starting again from scratch, yeah? This is more similar to human beings, yeah? So when we do things wrong, we have this time life thing. And then what is done wrong is done wrong. We cannot just reset and start from scratch. Yeah, we need to find ways to overcome what was done wrong and get better now and start to do it right. That's what we do. So in a never-ending learning approach, you see that those four key ideas and the idea of self-supervision and self-reflection brings the system much closer to this situation in which you have a lifetime instead of independent episodes that you can run. So those are also differences that you can find when you compare reinforcement learning with never-ending learning, okay? I highly recommend reading this paper. And based on these initial insights that the paper gave us, let's go for some more variations on these ideas of what is never-ending learning, continuous learning, and so on and so forth. And to go over now, let me start saying that the idea of lifelong learning is really not new. Yeah, so it's been there for a while, and we have very nice and interesting works that I will call here more classic works from the 90s, for instance. And in those kind of proposals and approaches, the paradigm, sorry, they were all based on this idea of I can keep learning, accumulating the knowledge over the tasks, and then use this acquired knowledge to go and solve different tasks and solve better the tasks that I was solving before. So it is there in the ideas of lifelong learning. And if you see, most of these are very related to key ideas number 1, key idea number 2, and key idea number 4 in never-ending learning. Yeah, maybe if I am going to select something that is different or is not touched, let's say, by lifelong learning, would be the ability of creating new learning tasks. That usually was not mentioned there before. Maybe because at that time, we were in a time where the other key ideas were not so consistent yet, and we were building upon the initial, or we were paving the way to get here. And then when we proposed never-ending learning, it was nice timing, let's say, to have the ability of adding new learning tasks too. And here, what I also would like to say is that by no means it's possible to say that one approach would be better than another. So for instance, I don't think that you guys should always choose to build a never-ending learning system for every system that you guys would like to do. Yeah. So in many cases, reinforcement learning would be much better than never-ending learning system. In other cases, just doing the continuous learning with self-supervision, lifelong learning, as we are saying here, it's better. Sometimes you don't even need to do the reasoning and you can have what you want. So the point is, depending on the goals that you have, it's important to know those key ideas so that you can think and plan. And then during the design of your model or your system, you can check whether that would make sense to improve the abilities that you want or not. Yes, so this is why we are discussing different approaches here. So then back here to our lifelong learning or learning to learn approach. This is actually, to my view, what started to bring concrete results to the area. Yeah, so that's how I see. And those works done in the 90s actually brought lots of light to the problem. And based on those other earlier approaches, not so early as the 90s, but some approaches from 2000, 2005, and so on, start to work on that. And those ones that I'm listing here, they follow this notion of task environment. And task environment for this type of lifelong learning or learning to learn approaches define actually a set of all the tasks that may need to be solved together with a probability distribution over them. So you have there all your tasks. And then what you do is you as a system, yeah, that is lifelong learning one, you observe those tasks and you sample. And usually this sample that you do is IID from the task environment. And that's usually how those models go. And the foundation and the more theoretical approach on this started and is based on this idea. You have a task environment, and then in that environment, you have a set of all tasks. They follow a probability distribution, and then you sample, IID sample from that environment, the tasks, and go solving them to try to get better. So that's usually how it goes. Some evolution on this, and now we are talking a little bit more about theoretical results here. Balkan showed, and Bloom and Vempala in Code 2015 showed some initial thoughts on how to actually relax this idea of doing some relaxation of the IID assumption. Yeah, but to do that, actually they kept some constraints in how would the classification be. So it would need to be a binary classification with linearly separable classes, and also with some properties in the data. Yeah, so data distribution should follow some isotropic log concave data distribution. Okay, so but this is interesting work for you that is more interested in more theoretical approaches coming from lifelong learning paradigm, and they are usually based on this idea and the extending or automatic creation of new learning functions is not here actually. Most of this work will not actually mention that part, but they would be interested in knowing how to get the most possible if the set of tasks that you want to solve is defined, yeah, the way it is. So, and here is a very good way of putting this. Maybe it's saying, okay, if you don't have key idea number 3, your model will keep learning continuously, trying to achieve the best that is possible with that set of tasks that is proposed initially. Yeah. So if your design, initial design on solving the problem is really good, and for instance, you took advice from experts in the field, so you modeled and designed your system architecture with all the tasks that really are needed, okay, you probably will do really good without the need of adding new learning tasks. Yeah, so you see that there are many situations in which the key idea number 3 will not be essential, and usually when you see papers on the literature, in the literature saying lifelong learning or learning to learn, they will be talking about this idea without caring much about working or discovering new learning functions. Okay, we are going almost to the end of the lifelong learning or learning to learn. I would just mention one more work here, which is Pentina and Lampert 2015 that also worked on the relaxation of IID constraints in the environment task of a lifelong learning algorithm. Okay, so here, differently from Nina Balkan in the last paper we mentioned, they here use a Pack-Bayesian framework, and then they propose these two relaxation for the model. Okay, this is enough. I'll not go into those details so much, and I'll just try to put this in a very shallow way of comparing some of the different names that we find in the literature. Let's do the first comparison that we have, and we have never-ending learning approaches, and we have lifelong learning approaches. Usually they would be having the same motivation. They would be sharing most of the ideas that are behind the models that are produced and proposed. But maybe if we can point out one difference here is the key idea number 3, that usually is not part of what lifelong learning proposals take care of, okay? And never-ending learning usually takes care of that one. That is a good comparison for the first one. And now we will add now, so you see that I'm coming back in here and just saying that we were working on lifelong learning or continuous learning, as we mentioned before, or learning to learn algorithm, and so, or approaches. So all of this would follow usually this idea here. There is this very tiny difference for another naming that is common in the literature, which is not lifelong learning, but lifelong machine learning. So this was coined, maybe this term, as I know, was coined by Chen and Liu in 2016. And they have this book about lifelong machine learning, which is a very interesting, this one here, this reference is a very interesting reference and became a book. And they have also this online version of the book that they update. I don't know the frequency of the updates, but they have some updates in the version that you can find online too, okay? So this is then another different naming that you will find in the literature. They add this machine learning here, not only lifelong learning. The key ideas behind this are pretty much following what we have seen so far. So first, continuous learning. Second, knowledge accumulation and maintenance in the knowledge base. Third, the ability to use past knowledge to help future learning. You see that here, the lifelong learning in this view for Chen and Liu 2016, this lifelong learning, it needs to learn a series of different tasks and then possibly never ending. So keep doing this. And in the process, it becomes more and more knowledgeable and better at learning. You see that this definition that we find here is really great and overlaps a lot. It's very similar to what we have in most of the other lifelong learning or never-ending learning. Yeah, I would say that key differences that are easier to notice is first one, Chen and Liu consider that the way for storing the knowledge that was acquired and will be used in the next iteration is a knowledge base. So they put this in their definition of the problem. And if you look at never-ending learning or the previous lifelong learning approaches, this was not stated in the definition of the problem. Yeah? So we could use whatever was more adaptable there. I will cite the example of NELL uses Theo, I already mentioned that, which is a frame-based knowledge representation from the 80s, actually. And so we have Theo 2.0, actually, as we used to call, but it's a different way of doing the representation. And we can transfer that. We export, actually, what is in Theo to RDFs, for instance. But RDFs or triples or this kind of knowledge bases that nowadays most of us see around was not originally what NELL was using. And here they put it as a very concrete definition. In the lifelong machine learning, the accumulation of the knowledge in many times do not come actually to the to a consolidation file or knowledge representation. Yeah, most of the work in lifelong learning that I was showing here before. Yeah, so I just went back one slide. These guys, many of those or most of those will actually be based on a neural network architecture. So in that case, the knowledge that will be accumulated and maintained for those approaches will usually be in the parameters of your model. Yeah, and then so this is also different from this view here. So I would say that lifelong machine learning, as described by Chen and Liu, is actually an approach in which you can get the ideas of lifelong learning, but not using neural network to represent it, the knowledge acquired. So instead of using the parameters of your model, you go for a knowledge base, yeah? And initially, it was not necessarily defined having the ability of creating or proposing new tasks. But what is very interesting to see and make us very happy with all of this overlapping of these ideas is that in the online version, you will find of this paper or this book, sorry, that there is also what is called enhanced machine learning or lifelong machine learning definition. And in this enhanced definition, we actually see the addition of the key idea number 3, in which the system should be able to propose new learning tasks on the fly, which makes lots of sense. Yeah, so I like actually this idea of adding this to their definition. And then if I would put together all of these things on how different we would have, initially, I would say that lifelong learning, here is lifelong machine learning. My title is wrong here, sorry about that. So you see that this here analysis or comparative analysis is from NELL or the key ideas that we found on NELL and the lifelong machine learning here. It has clearly defined the key idea number 1 of using multitask, multi-view. It has clearly defined the key idea number 2 that you should reason over the learned knowledge. I would say here, I would add that in addition to having it clearly defined, it also has clearly defined what you should use for this, yeah, which is an ontology. So they make it clear that we should use an ontology. And the key idea number 3 was not very clearly expressed in the original, I would say, definition, but is actually in the enhanced definition there. So I would say that if we base our analysis, comparative analysis on the enhanced definition, yes, it also brings the key idea number 3 to the problem, and key idea number 4 is there too. So it's very interesting to see this convergence on what would be interesting to have in a never-ending learning environment or system that we see so far. With this, I kind of cover most of the different namings that we can have for lifelong learning, never-ending learning, lifelong machine learning, continuous learning, and learning to learn, and so forth. This is not supposed to be written in stone, you see. It's just giving you an idea why people call it in different names. So usually lifelong learning go more for neural networks based models. Unless it is lifelong machine learning, then not necessarily. And usually the lifelong learning or continuous learning or learning to learn that are based on neural networks don't take too much into account the idea of extending or creating new learning tasks, okay? At least not in most of the works that we see on the literature. On the other hand, the never-ending learning and the lifelong machine learning, yes, they usually take into account those characteristics. We are 2:30, so it's time for us for a break. I would like to ask for more questions before the break. If you have, please just type them and I can answer one or two. And then just to give you now the good news, yeah, after the break, we are going to focus just a little bit more on, okay, what is this ideas, Estevam, that I see all out there about catastrophic forgetting and capacity saturation. So how people that work with deep neural networks see this lifelong learning thing. So let's just take a look at this and make the last difference analysis here, in which I will say there are approaches in which you use a single model and your model must take care of everything of the continuous learning. And there are approaches in which you have many different models coupled together and they will take care of the never-ending learning. So we'll see this. Then we finish the idea of lifelong and never-ending learning approaches. We quickly go for some easy ways of defining a question answering system. And then we start to see how to put them together. There are 3 papers I want to share with you that already did it. And then after sharing about those 3 papers, we will also see, okay, and what else can we do? Yeah, some very nice ideas are already there in those 3 papers, but there are some other things that we might be wanting to check if we want to build our question answering system that is based on never-ending learning. And that's what we will try to do after the break, okay? So if you don't have questions, it's okay. We are going to go for the break, and as described in KDD rules or definitions, we should be back by 3 p.m. Pacific time. So in about 28 minutes, there is one question here, and I'll just read in the guys that want to go for the break, you can go. And the question is, replacing existing relationships, tasks, instead of inserting new ones would be a way of improve the system without increasing complexity. This is a very, very nice question. And I would say that this would be a proof that your system could get the property of self-reflection. You see that you have a task, you are not really doing much with that, and that task is really not helping you the way you thought, or that task was proposed by your system designer and it's not really helping much. So then, instead of keeping that task there and adding extra ones, the ability of coming back and see, okay, you know, this task here is not helping me, and maybe it's time for me to stop to worry or caring about it, so that my system doesn't need to grow indefinitely so big and so on and so forth. That's really, really interesting way of seeing this management of complexity. And I would say, Arthur, that your question is so much related to this problem that comes whenever we are talking about catastrophic forgetting and capacity saturation. That is exactly what we are going to do, discuss after the break. So thank you so very much. The short answer for now is yes, this is a great way. I love what you just said. I would, if I'm investigating or working on that, I would try to investigate that in a way showing self-reflection ability of your system, which is great. I actually didn't see many, I don't remember actually seeing this being done exactly the way you were seeing. So it's a very nice way. I agree that it makes total sense to try something related to that. Okay, I will discuss a little bit more after talking about catastrophic forgetting and capacity saturation after the break. So thank you so very much. Enjoy the break. Unfortunately, we are not all together there to talk a little bit more during coffee. But yeah, go there and we'll be back by 3. So about 26 minutes. Okay. Thank you. I will stop also here the camera and I'll be back soon. Hello all. I'll give some more minutes. Let me see if we are all back. I will stop sharing here so I can get back to you guys. Might be that we are all here again. I will start just putting back, like recapping what we just saw, so we give time for the ones that are just rejoining right now. So let me start sharing again. And what we have been doing during the first half of this tutorial was actually taking a look into 4 key ideas that are present in the paradigm called never-ending learning, yeah, for machine learning systems. And usually that paradigm is focused in building systems actually that can perform the learning process in a continuous way, and we call it never-ending learning. The first key idea that is in that paradigm is actually that you should do your learning in a multi-view, multitask learning way. The second one is that over the time, every piece of knowledge acquired from your previous learning steps should be used in a way that it can help you to make it better in the next step. So let me just get back a little bit on the key idea number 1, just to reinforce the following. In key idea number 1, we are taking a lot of different functions or models, yeah, in your system, or learning tasks, and then views on those. And we are trying to benefit from using one to help the other, yeah. But this is not actually necessarily reasoning about all the knowledge that was acquired. So then in the second one, yes, we are now thinking about, okay, you have knowledge acquired during the process of solving this problem you're trying to solve. So use it to perform inference and reasoning over it, and now find out better ways to solve your problem. The third key idea is that your system must be able to propose, identify, propose, and deploy new learning tasks on the fly, so that you can avoid reaching plateaus or getting to local optimal solution in what you're trying to solve. Whenever the initial set of tasks, for instance, is not good enough or is not big enough to help you solving the problem. So you should go for it. And notice that in this key idea number 3, it's important to mention that we are not just talking about the ability of generalizing. So let's think a little bit about question answering, for instance. When I'm building a question answering system, I would like to build a model that can learn to answer questions. And I expect that my model can answer questions that were never seen in the training phase of my model. Yeah, so I do expect that my model can generalize beyond what was in the training data. But that doesn't mean defining new training tasks. Yeah, that is still using the very same learning task or training task or function to be solved, but expecting that this learning process can generalize, can go beyond the training examples that we're seeing. And the fourth key idea that we are talking about here is how we actually should use all of that all those 3 first ideas, and use a design of the system in which the tasks and how they are solved are done in a cumulative way, in which learning one of those tasks will help you to learn better another one. So yes, that's what we've been doing. We saw that never-ending learning is one approach that we can take and has all those 4 properties. We saw that this idea of getting a system to learn over the years and getting better and better with the accumulated knowledge that is acquired through solving the task is not new. And actually in the 90s, last century, there was this starting works on lifelong learning. And those were usually focusing the 3 of those 4 key ideas. Usually the third key idea, which is generate new learning tasks on the fly, was not there. Yeah, so that is one difference that we find from never-ending learning and the lifelong learning systems that we saw. And in that area, there is a bunch of work being done nowadays that is really interested in the formalism and theoretical results on how can you having a predefined set of tasks, how can you now define your environment so that you can take the most out of the tasks that are defined, so that you can use previous knowledge or different knowledge from the different tasks to solve better your current problem. Usually those works, they go towards how can I relax the IID assumption that I have when I have the environment tasks or the task environment, sorry. So that's it. And then we also saw that in addition to that lifelong learning, which is also continuous learning or learning to learn, we also another way of defining this type of approach, which is lifelong machine learning. And in this one, usually the key idea number 2, which is to perform reasoning over what was previously learned, is set and more concretely defined as in using a knowledge base to do it. And it can or cannot take the third key idea depending on which of the definitions you use for lifelong machine learning. Yeah. Another key point that we discussed is that in traditional lifelong learning, it's very common to have a single model trying to solve the problem. And this single model should acquire experience over the years or over the repetition or the interactions that are done to solve the problem. And because of that, because usually we are talking about one single model to keep acquiring knowledge, using the acquired knowledge to become better and better in solving not only one task, but many of those interrelated tasks, it might come a problem which is called catastrophic forgetting. And another one that is very related to catastrophic forgetting, which is called the capacity saturation. So those two issues might happen, and they are more discussed in the lifelong learning community, because those works usually are based on neural networks. So a single model instead of a system. You have a model to try to implement all those three key ideas, key idea number 1, 2, and 4 from the NELL approach. Yeah. So talking about that, this is the last work we want to see about never-ending learning and lifelong learning approaches. And we are taking here Sodani, Chandar, and Benjo, 2018 and 19. And these works, they are very interesting in the sense that they propose one initial discussion very similar to the one we are having here in this tutorial. So it brings light to the fact that there are many different names whenever you are talking about lifelong learning. And here for the authors, they list incremental learning, continual learning, explanation-based learning, and never-ending learning as being several names for this main idea of keep continuously improving and making better and better by keeping learning more and more. Yeah. So you see that they don't do really a more crisp definition or division in what those methods usually do. But I would say that the incremental learning that is seen here and the continual learning, they would go really very similar to key idea number 1, in which you do self-supervision. Yeah, not necessarily the incremental learning, not necessarily bringing the multitask, multi-view idea, but doing self-supervision. The results that are done are acquired, so they can be used in the future to do it better. In incremental learning, we also have this idea that is a little bit different from key idea number 1, of never-ending learning. So the intuition that your model can be updated as long as you see new examples that were not actually captured by the previous training tasks. So those are characteristics that are there in incremental learning. And then the other ones we already have kind of an idea, the explanation-based learning from Tran 1996 and 2012 are in the list of works that we characterized here as lifelong learning. So that's how they start and how they position these different names in this paper. And then it comes to the interesting fact that we already discussed. Yeah, for the lifelong learning system, they have the idea that these systems would be more effective at learning and retaining knowledge across different tasks. So this is exactly characteristics of key idea number 1 and 2. Yeah, and by using prior knowledge and exploiting similar across tasks, they would be able to obtain better priors for the task at hand. So this is kind of similar to use or exploiting the idea, key idea number 4. Yeah, so how you put together those similar tasks and use them to learn better each other. So you see that key idea number 1, 2, 4 are here. And one thing that I already mentioned that is different is that the focus is very much on doing it using neural network. And nowadays, usually talking about deep neural network. Yeah. So you have a single model. You don't have actually a system with many different functions. You have a single model that is still trying to learn many different tasks to get putting them together, but not in independent models as we saw in NELL. Yeah, because you are now talking about this model with these hidden layers that are actually being updated all the time, comes because of this comes all these two issues called catastrophic forgetting and the capacity saturation. I'll just kind of follow what the author told us about catastrophic forgetting, which is kind of intuitive idea that if you keep training your model and the data that is arriving keeps changing, and you keep training for new tasks and even more tasks and so on and so forth, at one point, if you, since a long time, don't see the original tasks that you were trained for, you will forget. And so with time, instead of becoming better in the original tasks that you started, if you start to add new tasks, related tasks, and training for those and so on, you might become worse in the original tasks that you were originally trained, because it's been so much time that you learn that you don't even remember. Yeah. So that's what can happen if you're training a deep neural network, because sorry about that, because in training a deep neural network, what you are doing is just adjusting the parameters. So if you keep adjusting the parameters towards tasks that are too different from the original ones, surely those parameters will tend to come farther from what they should be for the initial tasks. Yeah, so it makes sense. And it's something that you must keep an eye on if you are trying to train your model on many different tasks. And so that it might happen that one task might be for a long time without any training example shown to your model. So this is a problem that is identified, and that, as I said, the consequence can be becoming worse at solving one specific task instead of becoming better. So this is a problem if it occurs. The authors also mentioned that in this work, catastrophic inference is also a name used for the same approach or the same issue that is faced in their work. Notice that catastrophic forgetting means that your parameters are being updated and adjusted towards different things, and then you actually don't know how to solve the original task. A different thing is capacity saturation, in which the models actually have a fixed number of parameters. So you have a fixed number of parameters, and you want this model with this fixed number of parameters to solve a predetermined, let's say, number of tasks. Yeah. So for sure that if you start to train too many tasks, what will happen is that even if you never forget to add examples from the original or the first task that you were trained, so you are all the time trying to come back with those examples, so that then you don't have the catastrophic forgetting. Let's say you were trying to avoid that doing this. What might happen is that you don't have enough parameter to fit all these different tasks you want to train. And then you're gonna have collision. So you're gonna have actually parameters that will have to be changed to accommodate some new tasks, even though you didn't forget the original one. Yeah, you were training with those, but now you need to change these parameters to accommodate new tasks that arrived. So this is a problem very relevant and common whenever your model is not big enough, let's say, for solving the complexity of the tasks or the task you are trying to solve in deep neural networks. Notice that both of them are kind of interrelated. Yeah, so catastrophic forgetting and capacity saturation, they are usually related. It's important to note that surely capacity saturation can lead, as I told you in the example I just gave, catastrophic forgetting. So capacity saturation can lead to catastrophic forgetting. But it's not only the only case. Yeah, the other example I gave, if you just don't show examples of one task, that task will be forgotten too. So that's another possible way. And there is so this relationship in between those two issues. And it's important to notice that even though if you get a model with more and more parameters, so let's imagine you get a huge model with a huge number of parameters, then you are kind of mitigating the problem of capacity saturation. Yes, surely, but you are not actually doing that. You will not be able to guarantee that catastrophic forgetting will not happen anyways. So it's very difficult problem here to be sure whenever you are really avoiding those two issues when you're training a single model. And that's a very important problem that people don't actually put so much attention up to nowadays. Yeah. So authors in those two papers, they are really calling attention that whenever you work with these models, you should take that with more care. It's not that we don't find works dealing with those issues. We do find, I'm not saying we do not, but in many papers, nothing of this is actually taken into account. And in some cases that might actually be impacting the results. So it would be important to really always keep an eye on this kind of things, okay? If we are talking now about a lifelong learning, then those two issues become even more relevant, because then you are talking about things of retraining your model forever, you see? So you are adjusting the parameters forever. So the risk of the strategy of parameter adjustment you are using, forget about keeping, remembering about specific tasks and so on is high. So you should pay attention on that. And also the risk of capacity saturation happening is also high, because you are training indefinitely. So those two become even harder problems or more relevant problems whenever you're talking on trying to make your system or your model, in this case, a never-ending learning or continuous learning or lifelong learning one. But in addition to call attention to this, and I am using their work here in this tutorial mostly to call attention to catastrophic forgetting and capacity saturation, but the paper goes beyond this actually. The paper brings very interesting discussions related to what we are discussing here. First of those, they present some properties that a model that is trying to become a lifelong learning model should have. and those properties are related to things we discussed here. The first one is knowledge retention, and knowledge retention by those authors actually means that, you know, as we solve some new tasks, we should not forget the old ones, which makes total sense. Yeah. So, and it's previously mentioned in my example about training for a long time. The second issue is knowledge transfer. So whenever I'm trained for one specific task, what I learned should be transferable to the other tasks that are related and that are in my set of tasks to be solved. If I do this, it helps a lot actually to not really prevent, because you cannot guarantee that you are preventing it, but it helps a lot to work towards mitigation of catastrophic forgetting and capacity saturation, because you are actually getting results that will have influence in keeping your parameters suitable for the older tasks too, as you can transfer what was just learned right now. So this is interesting. Parameter efficiency. So here is another issue that is called, and this is related to the number of parameters in the model that I should have. Yeah. And here is the issue related to the question that was placed before our break. So Arthur just asked about this: should I, in a system, in a machine learning system that is a never-ending learning system, instead of being adding new tasks all the time, so that it would grow too big and complexity will become maybe intractable or something like that, should I replace functions or tasks instead of adding new ones? So yes, and I said yes, that makes sense, mainly if you notice that the task you were replacing, so you were dropping, was not really contributing to what you were doing. Yeah. If you are working in a lifelong learning approach in where you are now using a single model only, so this replacement of tasks would be even more relevant, because here is not only that latency will be a problem and you have to wait too much, or it will be intractable to train everything in time or things like that. No, in the system, usually that's what would happen. But here in one single model approach, what would happen is that if you don't have enough parameters, or if your parameters are if you don't take care about how many different tasks you have, yeah, so that your parameters can accommodate all of those, the catastrophic forgetting and capacity saturation will happen. So then it becomes even harder or even bigger problem than just latency or not having machines powerful enough to run and things like that. So this is a very interesting point. And you see nowadays that we are talking about transformers, yeah. And you see, oh, there is this new transformer that now has n extra billion parameters, and then we did much better. So you see, this is totally related to the problem we are discussing here. So if you take now as an example GPT-3 that extended the number of parameters when compared to GPT-2, and you see that the results really were boosted. And you see that then the limit in the number of parameters that you have really can have impact in the task you are solving. Yeah, because there is no much big other differences from those versions other than number of parameters. There are some few, but the main difference from GPT-2 to 3, for instance, is actually the number of parameters. So it's interesting to see how they can really affect the model you're using. The model expansion is another issue in this case. So if it is to be a never-ending learning or lifelong learning approach, your model would maybe need to be able to expand itself. And now by like expanding itself, we can see it very similar to KDD number 3 in the sense, oh, the model can identify new tasks, yeah, to learn. So that's what I told you guys when we were talking about extending the ontology in NELL, for instance, adding new relations, or and then using those as new tasks to be learned. But here, actually, this goes a little bit beyond. It has its overlapping on that idea, I agree, but it's also more specific to the problem that the expansion here is related to the parameters, for instance, that you can have. And then whenever you notice that even though you are not adding new tasks, your model cannot support all the tasks you are running right now, it would be important to know how to detect that and now add more parameters, for instance, to your model, or making it automatically growing in some way. So this is very interesting issues. They are related to the 4 key ideas that we talked about. They are not all the same because, again, in this view here, we are talking about using a single model to try to solve the lifelong learning problem. But let's go to all of these are just comments. And so those papers are really interesting, and I highly suggest and recommend you guys to go for them and take a look at them. And actually the main contributions of the paper are related to, first, using a unification of gradient episodic memory models, so the GEM, together with a net-to-net framework. Yeah, so this would bring the ability for the proposed model to tackle with these 4 mentioned issues. So you see that they present this table in the paper, and they show that the GEM is able to work with this knowledge retention, also knowledge transfer, and the parameter efficiency, as well as the net-to-net. And net-to-net also allows us to do the model expansion. So this is a very interesting way of coupling together those 2 models to now make it more feasible, the idea of having a lifelong learning single model running. And I know that when I say single model running, and then I present you guys saying that they propose to use 2 different models, it might sound interesting, but actually the net-to-net is more a framework in which you can use the GEM, and that's how they do it. So I recommend the reading of this. It's a very nice paper. But let me also call you guys' attention to another contribution of the paper. So you see that this first paper is 2018, and the authors are claiming that, you know, we don't have a good environment for evaluation, or we don't have benchmark for evaluating our lifelong learning models and systems that are out there. So then they go beyond just showing this way of connecting or coupling together the GEM and the net-to-net, and they also propose one benchmark that is curriculum-based and help you to understand and evaluate whether the model we're proposing has characteristics that are desirable for lifelong learning or not. And what I think it's very interesting here is to see that the community as a whole is really starting to push towards this. Yeah, so in 2018-19, Sodani, Chandra, and Benji already mentioned this. Back down there in 2010, then 15, we worked again on this. There was this proposal now, but we failed in making it available as something for benchmarking. And then now authors for this paper are proposing a benchmark, which is great. And then Platanius, Saparov, and Mitchell also proposed a new one in 2020. So you start to see the proposal of these benchmarks that, to me, is very nice, because if those benchmarks can play the role that was played for ImageNet, for instance, in computer vision and other stuff, that would help us a lot as a community to start to understanding better and identifying key points where we still need more research, and we need to be more careful, and we need to put more efforts, and so on and so forth, so that we can advance this area of never-ending learning, lifelong learning, and so on and so forth. So it's very nice this. Now, I will stop talking about this single model lifelong learning because of time. There are so many more interesting things to talk about this. But anyways, we need to go to our question answering never-ending learning here. And so I'll just leave you guys with some links for more details there is this review on continual learning for neural networks, which is interesting. There is also this nice paper that appeared ACL this year, which is not actually general lifelong learning or whatever, but is more focused in relation extraction in a continuous way. But it's a very nice paper. I recommend in the reading list too. Also, I briefly mentioned about reinforcement learning differences when compared to never-ending learning, lifelong learning, but I could not go through the ideas on putting together lifelong learning and reinforcement learning. Yeah, so time will not allow, so I'll just give you some pointers here on this topic. And I will mention that this topic and some other related topics like meta learning and some other ones are very well covered or much better than what I did here. Yeah, in a very recent tutorial last year, ICML. So last year, 2019 ICML tutorial on never-ending learning, Tom and Partha put together a very nice set of slides with a good video presentation that you can get. This is the website of their tutorial. I highly recommend if you are interested in more about specifics or independent ways of seeing never-ending learning, lifelong learning, and so on and so forth. And that we could not do it here because we need to spend some time in the other topics too. Okay, and also a not so recent tutorial that kind of covers many of these ideas and some a little bit more on the formalism that you could go. Actually, both of them, Tom and Partha's tutorial, as well as Brett, myself, and Bing tutorial in 2016. We presented KDD in 2016, so it's great to be back to KDD tutorials. In that one, and in Tom's one, and Partha's one, more formalism is presented. So if you are more interested in knowing how to go and formalize your ideas on this, I truly recommend going there. As you might already noticed in the version that we have here and we are discussing, I am not by coincidence, but focusing more on the ideas and a little bit less on the formalism and the theory. Yeah, I think there is room here for going for a different or a next tutorial in which we can formalize it a little bit better. And there is already very nice work going on in trying to more precisely defining a theory of learning. So in those two tutorials, you're gonna find links and more material towards that goal, okay? In our tutorial of today, I'm not going through that because it will not fit in our main goal. With this, let me ask here if are we okay, and do you think now you have an idea of key ideas behind never-ending learning, lifelong learning, continuous learning, and so on and so forth. So may we get into a little bit more of question answering? How are you guys on this? If anything passed and you didn't quite get or anything like that, let me know. Okay, I'll keep an eye on the chat. So feel free to keep writing, and if the question did not appear yet and it appears in some minutes, just go for it, okay? There is no wrong time for placing a question in the chat. Just feel free for going for this. But while you're still thinking or maybe still writing, let me just advance a little bit more and say that okay, we have an idea of never-ending learning and so on, but we want actually to be able at the end of this tutorial to apply those ideas to question answering. So let's just briefly define a little bit what do we mean by question answering. let's just cover a very, very shallow way, in a very, very shallow way, what is question answering and how community see it. Notice that you have already, I think you noticed actually already that we will not be able to spend so much time with question answering because we spend a lot with never-ending learning. So I want just to say that let's imagine that question answering is an approach in which what we want to have a model or a system that takes a question as input, that can have a source of information or knowledge to be consulted, and then based on this, the model or the system will provide an answer for the input question. So that's the basic idea that I want you guys to have about the process of question answering. And let's discuss a little bit of how this model or system can be. And let's also discuss a little bit of how the source of information or knowledge can also be, okay? So that we can frame a better reasoning on how to adapt the ideas from never-ending learning to this scenario. Before just moving to the next slide, let me just go for Dennis' question. And it says, thanks for Tora, very interesting. I wonder if you have material about personalization recommending system in never-ending learning. So that's a very good point, Dennis. A very, very good question, actually. And I would say that one of the ideas that I was having when I proposed this tutorial is trying to share a little bit more on how we are usually proposing to model different tasks in a never-ending learning way. Because I have not seen much of this in many of the subtasks that are usually present here, for instance, in KDD and other machine learning or language focused conferences. So to be concise in the answer is the following. I don't remember seeing, I'm not aware of a never-ending learning approach for personalization or recommendation systems that takes into account all the 4 key ideas that we mentioned here. But there are some interesting work done in recommendation systems or personalization in which continuous learning happen, for instance, and in which lifelong learning with a single model happened too, and in which if we took away the key idea number 3 of creating new tasks in recommendation system, for instance, the subtasks that are usually used, or there are interesting ways in which people are breaking down those tasks. And I'll be very happy to add an append or something. If the tutorial page here at KDD will keep these answers, I will add some related work to this in the KDD page. Otherwise, I will put in our tutorial webpage answers for all of these questions. So before actually ending the session, I will copy all of those. I will add there. And yes, definitely, there is some very nice ideas that can pave the way, let's say, for you to build upon and get even having all 4 key ideas for that domain. So thank you for asking, and I'll be sure to make sure to add those in the comments there. Thank you. So great question. I love that. And now I will just go and get back that we are trying to just check a little bit on how the model and system can be in this approach here that we are saying, and how the source of information and knowledge can also be. Let's take advantage here of a very nice textbook that is not actually focused on question answering only. It's more on communication, or more dialogue system and things like that. So Juravsky and Martin 2019. Actually, they have previous version 2018. Last one that is available on their website is 19. Probably there will be coming something this year too. Usually they can have time to update and generate the new version during fall. So we might expect that maybe even a new version there, which is a great book to read. It's a textbook style. And I would say that people interested in these areas, such as question answering, search, dialogue system, chatbots, and so on, that's a must not miss one, okay? So taking advantage of that, let's see that we have usually in the classic approaches for question answering, what people used to say they were based on pipelines. It means a sequence of different processes that were executed in sequence, most of those, and then at the end we would get the final answer. So a traditional way of putting a question answering pipeline would be having a question as input and then processing this question. So we have question processing, and we can have different approaches for question processing, but most common ones would be maybe query reformulation or query formulation. So you get the question, you translate that question into a query that will allow you to retrieve documents from your source of information that will be good candidates to have the answer that is needed to answer this question. So then in the question processing, we can do query formulation. We can also detect the type of the question, and it would help actually at the end of the process here when you are extracting the most, let's say, the most well-ranked candidates to answer this question, and you can use the signals coming from what type of question you have, so you kind of can expect some type of answer based on that too. Yeah. So type of question, type of answer, those two functions are interesting to have in a pipeline like this. Okay, so it goes like this. Usually you have a question processing, then you have the second step that usually is related to document or passage retrieval. And then after that, you have the answer extraction. This is very common. The size of each one of those steps can vary, and some pipelines sometimes just skip one of those and go straight to the other. It might happen too. It's interesting to notice here that the processing and the answer that is being provided at the end of the day is not is just getting the passage or sentences that you find in the text and providing it to the user. There is also a possibility of having answer generation in some classic pipelines and even modern pipelines, so that in that case, you don't want actually just to select one of the passages or sentences and provide as answer. You would like actually to take into account what you found in your source of information or knowledge, and then generate your own answer to be provided to your user. So that is also possible. For instance, Watson, IBM Watson question answer used to have an answer generation step here in the pipeline. In general, they also have very similar to the classic pipeline, with one first component here being the question processing, then the candidate answer generation, then the scoring of that one, and then the confidence or merging ranking, in which you could decide what would be provided to your user. So you see that here you have generation, yeah, not only the extraction. So that's a kind of different way to go, but also following the idea of a pipeline, a well-defined pipeline for your system to follow, okay? But after this transformer, so after Elmo and BERT and GPT and so on and so forth, T5 and so on, what started to happen is that systems or models, question answering models that are based on a single model, or what we would call end-to-end approaches, started to get very good results. So they start to be competitive with the pipelines. And so you can have end-to-end approaches, for instance, just getting these transformers as being the representation of your question and answers and answer candidates. So then you just give in an input question, you map it to your representation, transformer representation, and then you map all your sentences that can be candidates to answer that question also to the same representation or to a compatible space of representation, and then you just see what would you get as best match, for instance. So these approaches are very well explored in this tutorial this year, like June, I think 2 months ago in ACL. So Chen and E did a great job exploring this kind and some other approaches too. So also highly recommended tutorial if you're interested in factual question answering. So very good to go on this. And they show that, as I was saying, you can have now a single model and sometimes even what they call model retrieval free models. Yeah, that you don't even need to go and retrieve and then map. You just go and solve your problem using what your model already know about that. Yeah, so this is very interesting set of approaches that can happen. And you are considering that internal representation of what was learned by those huge models with this huge number of parameters can tell you now a lot of what you need to provide an answer for questions. Yeah, so those are interesting approaches. Surely they don't solve all the problems. Yeah, they are just alternatives, and I can tell you they are good alternatives. I've seen in the literature of the academic research and also in industry that it's possible to get very good results with this kind of approach. One of the problem with those end-to-end learning or retrieval-free models could be sometimes latency. So how can you really work with this and make it feasible to have very low latency for a real case scenario in industry, for instance, but they tend to be very hard to beat systems for question answering. So this is very interesting and again, highlighting that this is a good tutorial to go. In addition to these different ways of having the model or the system, we also have some other characteristics that are relevant when you are trying to frame or define your question answering system. It can be open domain question answering system, as we saw you can see in the ACL 2020 tutorial, but they can also be closed domain ones. They can be focusing, for instance, Miller 2016 that I put here. It's a classic on the movie domain. So you have specific domains, you have open domains, you have factoid or not. So factoid and non-factoid questions, meaning that whenever you are working with a factoid question answering system, usually the questions can be answered with a simple fact. That's what we mean. Yeah, so it's a short text, so 1, 2, 3 sentences at most, with a fact being used to answer the question. Non-factoids can go beyond, and then you can have many different ways of doing that. You might be talking about common sense, multi-hop question answering, opinion actually you want to get, and things like that. So it can be for subjective actually question answering systems can vary on that area too. Also still on the not really a very crisp taxonomy, but in possible ways you can define your question answering system. It depends on how is your source of knowledge. So you have IR based, so information retrieval based approaches in which IR techniques actually are used to fetch documents or passages, and then those are used as and are provided as the answer. So this is, for instance, very similar to the first pipeline I commented here in this tutorial. We also have the knowledge-based question answering system, in which you have a knowledge base, and then what you actually do is trying to map your original input question into ways you can search the knowledge base to find an answer there. Yeah, so this is another way. And there is many other combinations of all of those that we can have. So, but those are classic and traditional ways you can kind of set and define what question answering system you are interested in working with. Okay, so now just back here, what we want to do is just say that question answering system, actually the community is very active, and it started maybe with this idea of proposing benchmarks and you know, extending what they would have in the toy problems, original toy problems that were used to evaluate, assess, and measure how well your system were doing. They started putting more real case scenario benchmarks out there, and that also has contributed to start to have new models and new advances in the area. So I think that in addition to have this appeal of having personal assistants that really benefit from question answering system, also having the web search as something really connected to our daily lives, and this idea that web search should go beyond just providing you a list of web pages that you should search for your question, for your answer. So trying to answer questions from the web, all of this made also the enterprise system. So, you know, many companies with so many documents inside and wanting to have systems that can read all those documentations and bringing answers instead of just being retrieving what are the docs that would be maybe relevant to your question, so on and so forth. So all of this motivated really a boost in many different models and so on. And also, as I mentioned, the idea of new benchmarks boosted what the results started to appear. And talking about benchmarks and data sets related to this, I would highly recommend you guys taking a look at Parlay, which is this, as defined by their authors, a one-stop shop for dialogue research. I know we are not talking about dialogue specifically here, but they also have in Parlay this session related to question answering. So it's very interesting resource to talk or to actually read and investigate. And in that one, you will find many different tasks related to question answering. This is just a piece, part of the web page related to the QA tasks, in which you find many different data sets, and the tasks are also different depending on the data set you are using. So you also have state-of-the-art results for most of those and things like that. So it's a very nice place to visit to keep up to date on what the community is doing on question answering. And also to keep up to date on what community is doing, I would suggest now here that we should go and keep an eye on, not keep an eye, but go through actually some recent tutorials all this year. So I already mentioned Chen and E ACL 2020. This is a very good one for open domain question answering. We also have in SIGIR, ACM SIGIR this year, this tutorial on question answering over curated and open web sources, which brings us more of a perspective of information retrieval and is more database and things like that. So I think they are complementary, and they give you a very nice overview of what is going on in the area of question answering. So highly recommended here. I will not go through all of those. I actually think that the definition that we have, that we want a system, our question answering system will be something that will use a model or a system in the middle, and will take question as input, can be using a source of information or knowledge and providing an answer. That is the definition we will need. Yeah. In the examples I want to show later on, we will just add on top of this that maybe we will be simplifying this problem and working only on factual question answering that makes it easier to explain some basic ideas for adding never-ending learning concepts on this, okay? But before going to this basic definition of what we can add to never-ending learning, to question answering system based on the never-ending learning key ideas, let's go over some work that have already done that, and they contributed to this area, putting ideas from lifelong learning or never-ending learning into concrete case scenarios of question answering system. I will start our review on those with this paper from 2015, Borders et al. And the reason I'm starting with this, even though if you look at the title of the paper, Large Scale Simple Question Answering with Memory Networks, you see that it is really not focusing strictly in a never-ending learning way for going for question answering, but it paves the way to get there. So it shows some very relevant work and results that are very useful for our intention of using never-ending learning ideas to question answer. So let's just keep going through here and take a look on what they propose. The idea is to use what they call simple question answering. So this is their own definition of the problem that they want to work on. And as they describe or define this problem of simple question answering is actually the task of answering questions that refer to a single fact of a knowledge base. So you see here that they are defining a lot with this very single sentence here. So they want to answer questions that will come, the answer, sorry, will come from a knowledge base. So it's a knowledge-based question answering system. It's also defining that we are talking about a single fact. So it's a factual or factoid question answering system from a knowledge base. Yeah, so that's what they are interested in. So they don't want, for instance, to think about the problem in which you use a knowledge base, but you might end up having many different answers and then you need to combine them or generate another answer. They don't want to take a look in the idea of whenever you are looking for the answer in a collection of text or documents. No, it's just one single fact and coming from the knowledge base. The aim is to go beyond what they had as benchmarks at that time. And you see that I'm again hitting this stroke, like I'm saying, ImageNet did great for computer vision. It's not the only thing that helped the community to advance, but it is one of the factors that helped a lot. Never-ending learning systems community and lifelong learning models community are now starting to push on this too. Question answering systems or question answering community start pushing on that. So you see this paper is 2015. And they were starting to see, okay, let's go a little bit beyond the evaluation techniques that we build independently and every author or every team builds their own. And then at the end of the day, it's hard to compare and know what is working better and so on and so forth. So this is very nice. And I'm showing here to call attention that in 2015, they started thinking about that. So this is one of the examples of benchmarks that were proposed at that time. They used to have web questions as one of the benchmarks that was very used, and it was 6,000 questions actually benchmark, and they proposed this new one which was 100,000 questions. So it's really one order of magnitude or more, maybe almost two, and that's great. So the aim was going beyond that. And in addition to propose a good benchmark, I think that one key contribution here is that they proposed the idea of using, or not using, but embedding the question answering system to develop like this framework of using a memory associated to a neural network model. So And using a memory associated to the neural network model can be seen, for instance, as a way of consolidating the learned or the pieces of knowledge that were learned into something that can be used during the learning process of the network. So in some sense, this is actually very nice way of thinking about having key idea number two. For instance, in lifelong machine learning, they define key idea number two as having a knowledge base, yeah, that can be used during the process of learning. And here, it was a work that proposed having a memory associated with the neural network, and that memory could be used during the learning process without even needing to retrain the full model to take advantage of the knowledge that was there. So this, for me, it's a really, really nice piece of work that shows that you can really do key idea number one, in which they get two different tasks and they couple those together. And then to get this coupling together, they use the idea of having a memory incorporating part of one of those tasks, and it works very nicely. So this is very nice work. And I would say that they have contributions that are valid and inspired other works that were performed in question answering, lifelong or never-ending learning question answering. In that work, they also then show some results. They show that they can do better than some other previous works. In this is the web questions, as I mentioned, which was kind of standard benchmark, 6,000 questions. And here they propose simple questions with 100. So those are the main contributions of this paper. And as I already mentioned, they have this very nice way of putting together how you can do the multitask learning here. So they have actually two tasks being alternated, and this is very nice. They do reasoning in some sense because that knowledge, that memory is there and is helping in the answering of the neural network process, even without retraining the model. So this is very interesting. They don't propose new learning tasks, and it's okay. And those two different tasks that they work here in key idea number one are put together in a very nice way, in which learning one really helps, and they show it with the results help learning the other one. So this is very good work that put together these kind of things and show that we can start to adapt some of the key ideas used in continual learning, never-ending learning for question answering systems. Okay. The second work that I want to highlight here is Abu Jabal WWW 2018, and the title of this paper is Never-Ending Learning for Question Answering. So the idea behind here is actually to have a way of perform a continuous learning using a framework that counts on template-based, knowledge-based question answering, and they call it never-ending question answering, so NEQA. Well, how does it work? It actually just initializes the model with a small set of training data, and this training data actually is a small sample of templates, so that whenever one question is provided as input, you try to fit that question to a template, and if you can fit it to a template, then you know where the answer for that question would be in the knowledge base. And then you can just retrieve and answer the question. Whenever your input question does not fit in the template that you already have learned, or in the initial set of templates that they start the system with, then what happens is that they propose a similarity measure or semantic similarity function actually to try to identify new templates, so learning new templates, and then they use these new possible templates to ask for a human in the loop to label whether they would be correct or not. And depending on the label given by the human in the loop, they would add this new template for the next iteration of the system. And that's how they go continuously learning more and more. And here, so the continuity of the learning comes in this cycle of keeping adding new learned templates to your initial small set of templates. And they kind of couple together two different functions. And the first function is this syntactic based template definition that you have. And then the second one is actually the semantic similarity function that you try to learn or learn a different template. So that's what the system keeps trying to do. So those two tasks, it tries to, first of all, fit templates to questions, and then second task, try to find or provide or learn new templates in the cases where the fit is not good enough for the question that was given. And then they couple together those two, yeah? And as I told you before, there is a feedback component with a human in the loop that help the system to keep learning. An interesting point also in this approach is that even though they count on human in the loop to verify what are the new templates that should be added to the bank of templates, let's call it like this, as they describe here. So they have this template bank, and then the human in the loop just help you to really add there or not. But the interesting part of the work is that even when the human in the loop is not there, they try to use the suggested template learned by the semantic similarity function as the one to be used in the cases where the matching with the already existent templates fails. So, and they show experiments here in which surely the version without a human in the loop does not perform so well as the one with the human in the loop. So red is without human in the loop and black is with. But even in the cases where the human in the loop is not available, we can have good results. This, we have one here experiment in which actually without any here human in the loop, we have more, let's say, results that are higher, but this is in the number of templates that they are providing. So the number of templates can be higher when there is no human in the loop. It is kind of intuitive because when there is no human in the loop in their approach, what they do is they take the top candidate in a ranked list of candidates and they use it. So that's why this grows a little bit more than whenever you have a human in the loops, because when the human in the loop is there, it can say, no, none of those candidates should be added. Okay, so this is interesting work. The name is very appealing to our tutorial today, yeah? And they also show some results here comparing to other baselines if they were to be using the system not in a continuous learning way. Okay, so the baselines that they use are first this question answering on Freebase from CIKM 2015, not so recent one, and the other one is work from the same authors, but instead of the 2018, the 2017. It's kind of a version of the proposed approach, but without the continuity of the learning. Some more results from them. They also show results on the same web questions data set or benchmark that we just saw results from the first paper we discussed, okay? Yeah, you remember, if you remember, the results I showed there were having a F1 score of about 42, and they here get to 51, which is really good. It's losing here, not beating this work here, but it's a very nice result that they are getting. Other than that, there is this ablation component that they do. We are kind of getting a little bit late, so I will skip this and go for the analysis that we want to go here. And the analysis, when this shallow analysis that we are always doing here, just comparing against the key ideas that we have in never-ending learning, I would say that we have coupled multitask, multi-view learning here very well defined. There is no very well-defined way of reasoning over what was previously learned in this paper, but the paper really paves the way so that if they want, they now can start using the system and you know, consolidating the parameters and the results so that they can be used later on for reasoning. So I see that maybe that's even one of the ideas that they have because of the way they propose the system or the approach. They don't have any clear way of proposing new learning tasks. Maybe this is not even in their plan for the future, I don't know, but the paper doesn't show it, but they show an interesting way of having those two different tasks working together so that one can help the other. So this is very nice initial steps towards never-ending learning for question answering, and it's a nice work to look. They already implement so multitask using two tasks, and they are already implementing the use of those two tasks in a staged learning way. So this is good. Another paper that describes the idea of putting together never-ending learning with question answering is this. The title is Never-Ending Learning for Chatbots. In spite of having chatbots in the title, the main idea here is actually to have a chatbot that can answer questions, and they are not really focusing so much in the dialogue management, in the dialogue policy of this chatbot. It's more like focus in the case where you receive a question and you need to provide an answer. So it's very situated in the question answering scenario. And the main idea that they describe is actually they want to build a general knowledge learning engine for chatbots. So if you look at this, is like they are kind of transferring the problem to the construction of a knowledge base that will be useful for the chatbot, and the construction of this knowledge base can be guided by the question answering that happens in the chatbot. So that's the main idea, to continuously and interactively learn new knowledge during the conversation. So the idea is that you can improve or grow a knowledge base that is being used for you to answer questions during conversation. And then if you keep using it, the knowledge base will grow and you will be able to answer better and better about more questions over time. So the idea is to become more and more knowledgeable and better at learning during the conversation. They propose a model that is an open world knowledge-based complexion. That's how they define it. And they propose one technique called lifelong interactive learning and inference. So you see that by the name of the model, it's easy to see that they have this lifelong interactive thing that shows the presence of someone asking questions. So we keep going with this. So the interaction happens in a continuous way, in a lifelong way, let's say. And then also the inference. So the authors actually explicitly put here in this name of the model that they are interested in solving key idea number 1 and 2, on the tasks that they need to solve during the conversation. And they also have the inference, so interactive with solving tasks and performing inference over it. In addition to that, they give some more detail about the LILI model, and it actually has this main goal of formulating the inference strategy over the knowledge base. So this is one of the tasks that the system needs to solve. Then it learns the interaction behavior. So what should this chatbot ask and when to ask to the user if there is something to be asked. Yeah. And then it leveraged this acquired knowledge for the next steps of the conversation. And usually the idea is trying to validate what was answered by the user, and taking advantage of having this user there in the loop, which is a nice idea, a nice way to go. And then they want to perform all of this in a continuous knowledge learning way. Actually, 1, 2, and 3, this is wrong, so it should be 2, 3, and 4, yeah, because this number should not be here. So that's their proposal, and they clearly state that they are focusing in a scenario in which you can have a dialogue happening. So a human is in the loop, and then questions are being answered in this system. So this is very good scenario whenever the human interaction is going on. The results that I presented here in the paper actually don't compare results against some other baselines, because it's hard for them to put their model in the same context of other previous approaches. So what they do is they propose variations of LI, and actually they use also NELL's knowledge base to enrich one simulated user's knowledge base that can be explored by the system. Whenever the user is not there in the loop, you can simulate that, and the simulation is done by adding triples of knowledge in a user knowledge base and enriching it with NELL triples for the task. So you see that NELL is not used, for instance, as a comparative analysis here, even though the domain or the problem that is being solved is very similar. Yeah. So what NELL, one of the tasks that is result of NELL's learning is this continuously growth and population of open knowledge base. Yeah. So, but the way it is, we saw it previously in this tutorial, it's hard to compare. So for instance, Sahisnu, and Liu could not do this comparison because of this. So then instead they use the triples to help in the process as an external source of knowledge, which is a very interesting approach too. And if we go for our analysis of similarities with never-ending learning ideas, key idea number 1 is definitely present here. So they have a reinforcement learning model actually that learns to formulate this query-specific inference strategy, so that with this they know what they should add to the knowledge base. So that's why they say they are performing this open knowledge base completion task. And they also have the lifelong prediction here that put together this different task then to be solved during the process. So they have this different tasks to be worked with. Key idea number 2 is there. And if you remember, Liu is the same author from Chen and Liu, in which they define lifelong machine learning, and in which key idea number 2 for them is very related to having a knowledge base. So this is no surprise that they are actually using the knowledge base as one of the main ideas here in the paper. Yes. Key idea number 3, which is related to creating new learning tasks. In some sense, they are doing this because the creation of these new links or relations in the knowledge base happens. And then because of these new relations, they are now able to learn how to answer different questions. So it's kind of similar to the relation extraction or extension that I showed you from NELL. They do relations discovery here too, as we did in NELL. And then they use this for their model to propose new candidates for the extension. So this is similar to that task, so they can accomplish results on this. And they also do all of this in this cumulative way of doing. So their reinforcement learning approach here detects what are the similar tasks that should be used whenever a new question gets as input. So this is interesting. And with this, I finish the overview of the ideas that are already in some papers connecting never-ending learning and question answering. And now I'll try to go over a simple case study in which I will try to complement the basic key ideas that we saw for never-ending learning and how they could be maybe enriched, taking advantage of the ideas that were already explored in these papers that I showed you and what maybe can be further advanced and things like that. Feel free to interrupt me anytime in this part too, as I will be proposing some simple structures here and you might be in doubt or uncertain of anything, just let me know, okay? So my idea now is, okay, let's propose a simple case study with simple factual question answering. And then getting the result from this, let's see what of those key ideas we can add here. How different would that be from those papers that we just saw? And what improvements can we expect if we keep going towards that direction, okay? And I think that even though this is not actually the answer for Danny's question, I would say that the way I'm trying to show this here, it's actually valid for any domain that you want to try to add never-ending learning ideas to your problem, okay? So let's just take this simple case study here for factual question answering. And let's take this as a problem in a process in which you have an input containing a question and a set of documents you want to extract answers from, and the output will be an answer, okay? So the simple approach that you can do is, okay, let's build a single function or a single model to do that. You give a question, your model finds a way through the set of documents and provide you an answer, okay? So this is the very basic approach if you look it as a single function solution for the problem. But how can now, getting this, we think about using key ideas from NELL, yeah? So key ideas number 1, 2, 3, and 4. Well, sorry. Well, if you if you want to do maybe the most simple way of going for it, we could take advantage of these works that already have going on building a never-ending way of building knowledge bases. Yeah. So if I have a knowledge base, and I can actually count on that knowledge base to detect or to answer my questions, so then I can transfer my problem to the knowledge base completion, such as NELL, or this is similar to what was just proposed in this last paper that we saw. And then your question answering system would actually just try to figure out how to go for that answer that is already in the knowledge base. So you don't need to learn much on growing anything or never-ending learning of the model if you have a never-ending learning source of information. So that's a way to see it. And that would be, let's say, let's call this as never-ending learning question answering approach. But notice that I'm not trying to stay with this. I'm just showing that this could be an approach, and that would be very similar to what was done in, as I already mentioned, in the last paper that we just saw. That is also very similar to what was done in NELL and what we call Ask NELL, in which you transfer your model to translate the original question into a natural, that is a natural language question into a inference or information retrieval language or something like that. This actually was done in some sense in those two works. In NELL, we did that previously some time ago, but we actually never built the model. We just actually asked the users from NELL to ask questions, but with a previously defined template. So we have templates for a question on categories. We can also have templates for asking about relations, so two arguments, which is similar to what Reverb also did, yeah. But we never explore that model. But we could do just that, and then the never-ending learning here would be in the knowledge base and not in the question answering system. So it's not actually what I really want to go, okay? So let's go and apply these ideas of never-ending learning if we want to go for the answer extraction part of it. So you have a question, you have a model that tries to extract answer from documents and then provide the answer to the user. So this case study can be seen the following way. If I want to apply key idea number one, which is coupling multi-task and multi-view learning to this, we just can define different tasks and views for our answer extraction. Yeah. Then key idea number two, we store the metadata and generated data from the process of learning to answer the questions, and then we can apply inference over it. The key idea number three, I can just define a mechanism to identify the new type of questions, for instance, or the new relations or predicates that I'm interested in. And the key idea number four, I can just plan before defining all of those. But let me show a real concrete way of doing all of this, which would start the following way. You have a question, your model wants to go through a set of documents and provide an answer. So let's imagine that the single model approach could be, okay, get your input question, map it to an internal representation of this model. Also map all the sentences that you have access to the same internal representation or a compatible internal representation, and then just do similarity checking here to see what is the answer that is most similar to the question that you got and you provide it. So that would be a good way of going. Yeah, you can use this internal representation based on symbolic sparse vectors, or more dense vector representation using a transformer or something like that. Notice that what was done in Borders 2015, as I told you, where they proposed the memory neural networks, is kind of similar to using embedding as our representation here, yeah? But anyways, if I do that, take a look. I can now have key idea number one with two different views of the same task. The task is one only, which is I want to extract answers from a collection of documents, given that I received a question. But I can implement it in two different views. One is the symbolic view of representation of the question. It can be a bag of words, it can be part of speech tagging, it can be any of those more symbolic ways of doing it. And as for instance, was used in the previous work that we see, defining templates and so on. And the second view could be, okay, I'll go for dense representation of transformers, BERT, whatever, something like that. And then I could train them both. And then this is a good way of doing the key idea number four, or putting those two together so that one can help the other. The co-train algorithm is here. I will not go over this right now because we are almost expiring our time, but let me go and show you in practice how it would work. So let's imagine I don't want to start needing to have a set of question and answers already labeled to start with. So some initial labeled data. If I don't have, I can go and extract them from triples from knowledge bases that we have out there, public domains, yeah. And then I can generate, or if I have a knowledge base in my company, I can do that too. And then I can generate some initial labeled, automatically labeled question answer pairs. If for some reason I already have some question answer pairs, I can use those and then use them as our initial labeled question answer pairs. Yeah, so I'll call this set of data as L because it's the labeled set that we have. It can come from any one of those, and I'll show an example in a minute. So then whenever this initial set is done, it doesn't need to be big because we are talking about just initial seeds to start the process. And then you can train a symbolic classifier here that I'm calling hypothesis 1. And we can train, for instance, a dense vector representation classifier that I'm calling hypothesis number 2. Then from the source of documents that I am trying to extract my answers, I can use sentences, all the sentences from this document as unlabeled sentences or unlabeled answers. So every sentence is a candidate to be an answer, but I don't know whether it's correct or a wrong answer for that question. That's why they are unlabeled. And then based on the given question from our set of unlabeled question, I can now provide all the answers here and classify them as being correct answer or wrong answer based on this symbolic classifier, and also use the same thing about the dense vector classifier. And then I will generate actually the positive and the negative examples and insert in my labeled, self-labeled, in this case, QA repository. And that's actually what we do with co-training, yeah? And we repeat this many times. So notice that this is similar to the semi-supervised approach that we were looking in the beginning of this tutorial, and what tries to put guardrails so that we don't learn wrong stuff is actually the use of those two different views. Yeah, so this is one way of starting the process of the coupling of different views. How can I do that in practice? I can repeat these steps. Just for instance, triples from knowledge base, I can get Wikidata or Freebase or any of those knowledge base that we have out there. And we can randomly select triples, so subject, predicate, object, or I can select the ones that I'm interested in based on subject, based on predicate, or whatever. So I select those. And then from those, I can select question answer generating templates. So for instance, let's imagine you select from Wikidata the triplet George Washington, mother is the subject, mother is the predicate, and Mary Ball Washington is the object, okay? Based on this, I can generate a question, who was George Washington's mother? And I can generate an answer based on that triple. George Washington's mother was Mary Ball Washington. So based on that, or how can I do that? To do that, you can just define simple templates to start with, yeah? And these templates, you can just add different ways people would ask this, knowing what is the subject, knowing what is the predicate, and knowing what is the object. And you can also create templates for the answer, knowing what is the predicate, the subject, the predicate, and the object. Those templates work really easily to generate those sentences. And if I have this, so then I built already the labeled QA pair, yeah? So just to make it a little bit faster, we are not going to consider the case in which you already have the labeled data. Let's just take this from here. But let me say that if you are considering previously labeled data having questions and answers, then the extraction of the SPO is not so trivial here, yeah? But that's not a big deal because the question and the answer sentences will be already done or there, yeah, for you. So you do not need to use this if you have a knowledge base, but notice that I'm not using the knowledge base to answer the questions. I'm using the knowledge base to generate initial label data so that we can start our co-training approach. The negative examples can be generated using positive examples from different properties or predicates, yeah? And it can also, then later on, the co-training, we will use actually the definition of confidence of negative examples to add more positive and negative examples on this. So positive example could be, who was George Washington's mother? George Washington's mother was Mary Ball Washington. Negative could be, for instance, changing the mother relation to father, and then the answer would be George Washington's father was Augustine Washington. This is a negative example for the question, who was the mother of George Washington. Okay, if we keep on this, sorry, I just clicked wrong. Yes. And then I just want to add that these negative examples that you are adding can play a very important role, mainly if you are working here also with this dense representation, so transformers. So just to give you an idea, if I just embed sentences, and here I'm just using this Hugging Face sentence BERT to embed the sentences in a dense representation. And I got the sentence, George Washington's mother was Mary Ball Washington. And the other sentence that is George Washington's father was Augustine Washington. And you see that those are two sentences that are good answers for different questions, but they have a kind of high cosine similarity between them both. So it means that a transformer representation on those two sentences might actually end up taking to your system a high chance of confusing above those two and choosing one of those for the wrong question. So that's why it would be important in the beginning, trying to set some initial negative examples to show your model that even though they might have high similarity in this case, there are other signals here in those two sentences that should be considered, and they should not be used as answer for the same question. Just to give you a little bit more on this, if I say George Washington's mother was Mary Ball Washington, and now I compared similarity with the question, who was the father of George Washington, you see it's kind of still relevant, so kind of high semantic similarity, and that's what you should try to avoid by adding specific ways of having the negative example set, okay? If you are using this kind of transformer-based approach, another thing that you could explore is actually adding the mask term replacing the object if you build this from the knowledge base. Yeah, so you know what is the object of the question, you know then that you can actually, and you know what is the object of the sentence. So you can, for instance, try to identify this with the masked token. For instance, if you say George Washington's mother was Mary Ball Washington, you can actually oh, sorry, this is like the full sentence. So George Washington's mother was Mary Ball Washington compared to who was the mother of George Washington. We have this similarity. And now I can actually start to substitute the object of the sentence that you're gonna find in the sentence that are candidates to be answers. And as you know, if you know what are the objects here, you substitute them by mask, and then George Washington's mother was mask compared to who is the mother of George Washington. You see that we have almost the very same similarity score here, yeah? Having Mary Ball Washington, knowing this or not knowing this, so then you don't need to be fixing what is your example here, and you can find a more generic way of finding the possible answers for this question using mask, and you can even use more than one mask token and things like that. I will just go a little bit faster because of time. So okay, then you did that, and you have the symbolic classifier, which can be based, as I told you, in feature, manually defined features based on tokens, surface, string, surface of the tokens, or POS tag, or dependent sparse tagging and things like that. You can also have the second hypothesis based on the transformers and so on. And then you select what are the new labeled data, and you keep doing this experiment for some iteration. So this is the basic idea. And this is actually very similar to what was done in Abu Jabal WWW 2018. Yeah. But in our case, we use co-training with those two different views. And in their case, they actually have two functions that they couple together. They use the template base two, as we just saw here. And whenever the template base fail, then they use the semantic similarity. In our case, we actually try both of them together in a co-train approach. That's what I'm saying. That could be a little bit different in the work that they already provided. Instead of trying the second view only when the first one fails, you can try to put them together. That would be an idea to be used there. And but more important than that, maybe, is that as we learned when we were studying about NELL, more couple functions tend to help more in your system to keep learning and better learning without going for semantic drift. Yeah, if you remember, I mentioned that NELL has about 4,000 different coupling approaches for functions. Yeah, and also, theoretically speaking, if you have two different views as we had here, and you want to couple them together, you can use co-training to do this with some of the results based on the learning theory. And if you have more than two views of the same task, then you even can use some approaches for unsupervisedly estimate the accuracy of all of those functions or classifiers. And if you can estimate how accurate is your classifier, you can actually add this information and not use results from an inaccurate classifier to label data to train later on. So this is something you should take into account, that if you use more than two views, then you are now able to use different ways of validating, unsupervisedly validating the results you are getting. And then this can contribute a lot for what you are building. So if you can add not only two different functions, but add more functions so that you can now start to do the validation of them, even if you don't have labeled data. Yeah. So the more, the better in this case for having more functions. And what other functions or what other views can we have for this very same task, for instance? Okay, if we need to go for three, and I just propose two, one is symbolic, the other one is dense representation. Okay, if we can break down, for instance, the input question in SPO triples and the candidate answers also in SPO triples, so subject, predicate, object triples, then we can start now to work much better because we have more functions. So this breaking down into subject, object, predicate, object triples is also done similarly in Abu Jabal, where they put the question as being a question subject, a question predicate, and we don't know the object, yeah, because it's a question. And then we can also extract the as we don't know the object of the question, we can kind of extract the expect type of this question, and based on the type of the question, we can expect what will be the type of the answer. So even though we don't know this object here, we can estimate what type would that be, yeah? As described in Jurafsky, we can do that. And so we can create a function that is question type, let's say, and giving as input the question, we can generate the question type. And then for every answer candidate sentence that you have, also extract the SPO triples. And this sentence now becomes the sentence subject, the sentence predicate, and the sentence object, okay? And then you can now, instead of just checking the similarity of the question and the sentence as we were doing the co-training, yeah, those co-training were just trying to measure the similarity like that. We can measure the similarity of the full question and the sentence, or candidate, answer candidate. You can measure the similarity of the question subject and the sentence subject. And you can measure the similarity of the question predicate and the sentence predicate. We cannot measure the similarity of the sentence object and the question object because we don't have, but we can measure the compatibility of the question type that we found here and the sentence object. And if they are compatible, now we have signals to be using with this. And if we have now those four different functions to use in our question answer, or trying to identify whether that sentence is a good candidate to answer this question, we can also apply and use the idea, the idea that I just showed, that we can do this similarity in those two ways, yeah? The symbolic way of doing this and also the dense representation way of doing that. So we can actually have two different ways of applying all of this. And now I can actually couple all of those together, saying that, okay, if my similarity of the question and the sentence are high, and if I try the similarity of the sentence subject and the question only, it makes sense. And then if I try the predicate, yes, they make sense. The compatibility is high for the question type that I was expecting for, and the object that I got in the sentence. You see that I have more ways of double checking whether that example or pair question answer would be a positive or a negative way or example to use. Yeah, so you see that what am I doing here? I'm just trying to go over the problem that we want to solve and breaking it down in many different ways to solve it, so that I can put them, all of these independent different ways of solving in this nested way of coupling together more and more functions. Because then we can also start to apply to those functions what is, for instance, the expected accuracy of those. And then I can even weight how much I want to believe in the answers that I get by those similarities, and take all of those into account before actually going for deciding whether the sentence is a good answer or not. But notice that for now, I only worked on different views, yeah? Actually, I can break down here in the sentence, the question, but I'm working on the similarity all the time, you see? So this is the similarity, maybe compatibility. So I have two different tasks to be solved here, similarity and compatibility. But if I now take advantage of those ideas that we saw from the classic question answering pipelines, that we know that in the classic pipeline, we usually don't do just one model here, but we have the query understanding or query processing, then we have the document re-ranking, and then the answer extraction, and then finally the answer. So I can now start to work with this idea of having symbolic and dense vector representation, extract positive and negative examples as I just showed you, using the similarity and the compatibility functions that we can define. The similarity function can be defined over the full question and full sentence, or in the SPO components of those. And then using this, I can, for instance, generate from those co-training similarity and compatibility labeled data that can be used, for instance, to train a query understanding model. And this query understanding becomes another task. It's a different function, let's say F prime, in which I receive a question as input, and I want to get as output Q prime, that is the reformulated question that will allow me to perform document retrieval. And so F2 is my extra task that I am adding here, so that F2 prime receives a reformulated question Q prime as input, and will give me as output a set of documents that would be good candidates to have the answer for that question. And now I can start to use those functions to create a classifier, for instance, that would go something, or use this as features and autonomously define this hidden layer in a feed-forward neural network, for instance. Or I can even explore more symbolic features and just say that things like, if my F prime question equals to Q prime, and the answer extraction function that I created, giving the question as input and having F prime 2, so the set of documents that were returned by that reformulation of the question also sounds good, then the answer is correct with more evidence than if I was just using the extraction, the answer extraction function, and I have a validation with the query. So you see that I'm putting together more functions and more tasks, so different views and different tasks to help us adding more ways for our system to validate its own answers that will be provided, knowing whether they are correct or not. But if I look at this, so far, what I was talking was mostly in how to apply key idea number one. Yeah, I just created different tasks and different views so that we could couple together and generate training data and do things like that. So the key idea number four was also there because the way we proposed this breaking down of the sentence and the question in SPO definitely gave us some functions that are useful for better learning the main function, which is the answer extraction. So I would say that we could explore this key idea number four in this one too, in this approach too. And we could now think about what if we could add key idea number two. We didn't add yet. So key idea number two here, having all of those functions, what we could do is, for instance, store all of those in graph database with all of the information about all given questions, how what were the answer candidates for every question that appeared in my system, what was the SPO elements of those questions, the SPO element of the answers, what was the type of the question that I used, what was the pipeline elements of it, I mean, the query reformulation, what does it generate, what was the set of documents that was provided in the doc retrieval. And if I create all of this now, I can apply and store in a graph database, for instance. I can then apply traditional reasoning algorithms over graphs, like for instance, PRA, so the path ranking algorithm. And now it starts to extract rules to tell me what would make sense as an answer or not. So reasoning over what was learned before. So that would be an idea here. And for key idea number three, how can we now add new functions to be learned? We could try to propose, for instance, new predicates or similarity of predicates and subjects and objects from the triples in the way that we did in this work of EMNLP 2011 that you see in the reference here of this work, in which we were extracting or exploring the relation discovery. And the same thing that was done here by Hisnu and Liu that we showed here. So, but to be honest, this key idea number three, the way that is proposed here, kind of still transfers the proposing of new tasks to the knowledge base instead of the learning process here itself. Okay, so I would say that this is a very good open question on how to propose new learning functions for the question answering itself and not transferring it for the knowledge base. We are really late here, so I will just mention a little bit some of the open problems other than this one that I just mentioned. So in never-ending learning question answerings, and also kind of in never-ending learning in general. So I told you that we don't know yet how could we, when is it the right time to consolidate what was learned in a knowledge base or in a database or in a knowledge representation like Theo, and when is it that we should have actually that information available in what the current knowledge representation is already able to provide via inference. So you know that there are some pieces of knowledge that your collection of experience can already give you through inference. And there are some other ones that you actually have consolidated in the knowledge representation that you do. So one key problem here that I see is, should I add to my knowledge representation all the pieces of knowledge that I can extract via inference, or should I just keep using inference instead of consolidating it in the knowledge representation. This is an interesting problem to be worked with. And how to automatically discover what questions or relations are mutually exclusive, for instance, to make a better decision on what will be the negative examples. Because in the example that I showed for you guys, I consider that mother of and father of are mutually exclusive answers for the same question. But how can we now extend this for automatically detecting what would make good negative examples to our self-supervision system? Another one would be how to incorporate output to different functions in single models. So should we create all of these different functions and keep them working together, coupling with these co-training approaches or EM approach on training all of them independently? Or should we try to actually put all of them in a single model instead of keeping independent models running on? This is also an interesting question that we might be wanting to answer. With this, I will stop now. I'm deeply sorry that I went far beyond in time, but I am here for more time. If you have questions, please don't allow the time or the 5 o'clock time limit block you. We can still stay a little bit longer if you have questions, and I would be very, very happy to discuss and answer all of them. Thank you. So I have one question already here. That's great. Arthur again, would it be feasible to combine a never-ending learning system with a generative adversarial network to provide an unlimited amount of knowledge? So Arthur, this is a very good point, and I didn't touch during the tutorial because we could not really touch everything that we could, yeah? But let me tell you the following. For instance, in the industrial approach, where we have this question answering systems and we have feedback from the user, and this can be, for instance, for web search, you know, all the search engines that we have over the web. Whenever you do a search, or nowadays many people ask questions, yeah, doing search over the web. The web pages that are showed back to you, or even whenever the search engine tries to answer your question, you sometimes click on it, or you sometimes spend time reading what happened. So you take some actions that allow you, for instance, to kind of detect those actions as kind of pseudo relevance score on each one of the possible answers that you provide. Yeah. So also whenever it's a conversational agent, so when you talk to Siri in your phone, you see that you ask things to Siri, and then the way you answer, you can collect signals from that too, and take that also as a pseudo relevance score for the answer that you provide. And so one way that people usually use to incorporate the kind of unlimited sequence of question and answering and learning from this and improving your model of what you would be answering next based on all that you have answered before could be in a way using a generative adversarial network that just start, you know, providing, for instance, you can even start, there are some works in which they even start random, just providing, you see these adversarial possible answers that you can provide. And then based on the feedback that keep coming, you just readjust your model and then start to propose better and better answers based on that. And this is a continuous learning process that can go on and on. And in this setting, even though we don't have key ideas, much actually of key ideas number 2, 3, and 4, and we mostly just have the key idea number one of putting these different tasks of generating possible answers. You can have a task of making those answers more or less adversarial as you want, yeah. And then be in the process of generating those guys. Um, for instance, learning a language model that provide this. So just doing this actually could really keep going and improving your results indefinitely. And I would say maybe that's not a way of saying that they have the key ideas of a never-ending learning system, but they have the behavior of a continuous learning system that is capable of improving itself in a way that maybe it's hard to beat, trying to incorporate some of these other key ideas that we have. So depending on the setting of your problem, that might be a very good idea to go, even though you might not be exploring all of those key ideas that you have in the never-ending learning system. Does it make sense what I said? Does it go towards what you asked?
Yes, yes. I was thinking about collecting data when you don't have a lot of data. But in this case, when you have the human in the loop, you already have an unlimited amount of data. So depends on the problem, as you said.
I agree. So other approaches, and I'll try to point in the answer for this question, as I mentioned before, other approaches that I've seen when you don't have the human in the loop would be trying to flip the problem. Yeah. So let's imagine you have a language model, generative model that try adversarial, and with the adversarial proposed sentence that you have, you now try to get uh, having this as input, you can try to build a model to generate what would be the possible questions to answer this thing that you generated, yeah? And if you start to train your model to, based on input questions, generate these possible answers, and then independently getting the self-generated answers to try to come back to questions that appear in your knowledge base, this is kind of trying to mitigate the problem of not having the human in the loop, and trying to simulating how you could have your pseudo relevance signal here to validate or not your question or your answer, sorry, if it makes sense. But that's a very good point that you have. Very good point. I will also try to select some other stuff related to this and point to you in the sequence. I will stop sharing. We can share again if this comes necessary. Just to tell you all that I'm now seeing you all here, and I also see Arthur. I think Arthur is from Brazil by your accent, and I see Maisa also here from Brazil, which is very nice to have never-ending learning expert attending to this tutorial. Maisa, thank you so very much. Thank you all for being here. It was great pleasure. Feel free to ask any other question. Let me also do this copying right now. No, I can wait a little bit because I am the one who started, so we will not lose this chat. I just don't want to lose the chat history. So as I said in the beginning, I will also keep this chat history with the questions in our tutorial webpage, and I will add the answers there. So you guys, if you cannot, if I could not actually answer all, I will get back and try to also put some links to resources that might be related to the question that you guys asked. And you guys feel free to send me other questions by email too. And then you mentioned if you want me, I can add there in the tutorial page or not, or I just answer you by email, and I'll be happy to do either way, the way it's better for you. Okay, considering that we are 5 minutes more than what we were expected to have, even for the question answering session. Considering that I'm not seeing much questions or many questions appearing, we can end the session and you guys feel free to turn off whenever it makes sense, okay? Thank you very much for attending. It was a pleasure talking for you.
Thank you very much.
Thank you all. So I just copy it, and so we now are safe not losing the history, and I will end the session with this, okay? So thank you so much, all of you. Bye-bye, enjoy the conference. I hope to see you around. Do not hesitate to drop me a line if you want to talk more during the conference or not, okay? Bye-bye, enjoy your conference.